So, good morning, everybody, and welcome to our EASA AI Days, where we're looking now at our new roadmap, the AI Roadmap 2.0, and towards a more autonomous AI. We have around 100 people who are actually here in Cologne with us today. We have more than 700 who are actually joining online. I have a special message there to anybody from EASA who is joining online. Please, could you not use the VPN to do this, because as you know, that sometimes tests the systems a bit. So please go off the VPN if you are an EASA employee joining. Particularly for those who are joining remotely, we really need to keep to time on this, so I'll be trying to kind of move things along a little bit as we go through the day. We are going to kick off shortly with 3 keynote speeches. Later in the day, we're going to be using Slido during the question and answer sessions, and you'll get details of that a little bit later on so that you know how to get in to do that. Details on that will all come later. So now we'd like to start without any further ado. Our first speaker is EASA Certification Director, Rachel Deischler. Rachel.
Good morning, everybody, and it's my pleasure to welcome you to this AI Days in EASA as a hybrid event. It's good to see so many of you in the room, and I heard you are even many of you online. So thank you for your time. This conference is the first of its kind and promises to be particularly exciting. We have foreseen 1 day and a half of program for you. Today is day 1 of the conference. What we have on the program in particular is the unveiling of the EASA AI Roadmap 2.0, which is our updated regulatory strategy for a safe and effective integration of AI into aviation. We will also have many presentations and debates about the use cases of AI that can be foreseen for aviation, and in particular how AI can be integrated in an ever more autonomous aviation system in a safe way. Tomorrow is focused on MLEAP, Stakeholder Day. MLEAP is the name of an EASA research project, EASA managed, and it stands for Machine Learning Applications Approval. I had to check that before coming. And we will hear a lot from our research community about what is happening in the field of machine learning and learning assurance. We have organized this event with the goal to make it really a good occasion for all of you, for all important actors of AI and aviation, to come together and to discuss how we can pave the way for certification of AI solutions, which are opportunities for operations, but also for safety improvements in aviation. Before going deeper into our own regulatory strategy on AI, I think it's important to emphasize that artificial intelligence has real opportunities for aviation. At a time where tools like ChatGPT show the progress which is made by the digital industry in other sectors, AI is already making today an operational impact on aviation, and we expect further growth. For example, in air traffic management. Air traffic is recovering in this post-pandemic period and is anticipated to continue to grow in the coming years. AI algorithm can be used to optimize air traffic flow, for example, reducing delays and increasing efficiency. Air traffic controllers can use AI-powered systems to predict traffic patterns and adjust flight paths in real time. And for example, we are working with Eurocontrol and EuroCAE on a machine learning time-based separation use case that illustrates what kind of optimizations can be done. AI can also assist in conflict detection and resolution, providing real-time alerts to air traffic controllers when there is a potential conflict. This can be done through machine learning algorithms that analyze radar, ADS-B, or other sensor data to detect conflicts. This is the type of use case developed by the ATM Research Institute of Singapore, and Professor Samir Alam will tell us more about this this afternoon. AI can also be used to improve performance of air operations by improving situational awareness of pilots, decision-making, and communication. For example, AI can be used to predict turbulence or icing conditions, helping the pilots to make better decisions on routing. AI-powered solutions can also help detecting other traffic and help in prevention of mid-air collisions. These systems use typically camera-based deep learning algorithms in complement to ADS-B or other sensor data. You will hear about more of that also from Luc van Dijk from Daedalen later this afternoon. In maintenance, AI-powered tools can also assist in optimization of maintenance schedules by predicting the remaining useful life of components and helping to decide when there is a need to inspect or repair. This is the type of use case that was investigated together with Collins Aerospace in the frame of the Formula Innovation Partnership contract, for which we have published a report on our website a couple of weeks ago. So these were just a few examples of the type of use cases that are either already deployed or in development. And we expect more in the coming years for aviation. AI can help aerodromes in the detection of birds or unlawful drones. It can also help to support safety management system and much more. So where do we stand today? What we can see is that the opportunities are vast, but it's important to proceed with care. As with any new technology, there are risks and challenges associated with AI. There are concerns with the complexity and non-transparency of machine learning and deep learning solutions, as well as with the ethical implications of using AI to make decisions impacting operations and human lives. There are also concerns about cybersecurity of AI applications. To address all of that, it is important that we all together, regulators, industry stakeholders, representatives of the end users communities and AI experts work together to develop the right guidance, an AI trustworthiness framework for the ethical and safe use of AI in aviation. From our side, from EASA side, we have tried to take a proactive approach to address AI in aviation. Our program for AI our program team has been working hard to develop usable guidance for safety-related AI applications in the form of an EASA AI concept paper with novel certification concepts such as the W-shaped learning assurance process and the human AI teaming guidance. So does that mean that we are ready to certify AI solutions today? For assistance applications where the human remains fully in control of the operations, but which provide already lots of potential safety benefits, we are getting closer. We have published in April 2022 the first EASA special condition, trustworthiness of machine learning-based systems for general aviation products. For more advanced automation solutions, a higher number of hurdles are left to resolve. These solutions will involve more complex interactions between humans and machines and require a higher level of assurance. Autonomous operations are yet even further away from becoming reality. And we will discuss the associated challenges during these 2 days. By working together, we can pave the way for the safe integration of AI in aviation, but we need to be mindful of the amount of work that we need to do. I'm excited that today we will be unveiling the EASA AI Roadmap 2.0. This roadmap is extending the scope of AI techniques covered in the previous version, updates our timelines and action plans, and anticipates already a rulemaking concept. The AI roadmap and the deliverables are designed to be fully compatible with the technical provisions of the upcoming EU AI Act. This act is not yet released, but we have been working closely with the Commission and taking into account draft material to make sure that we are staying fully compatible with what's coming ahead in terms of European multi-sector regulation. We will continue to work closely with all of you, aviation stakeholders, AI experts, to ensure that AI is integrated into the aviation system in a safe and trustworthy manner. I hope that you will find these 2 days interesting for you and that you will have opportunity to learn something new and to meet new people. I'm pleased now to give the floor to the Commission. Online? Or? Yeah, online. Antoine Alexandre André from DG Connect, who will give us a bit more insight into the upcoming EU AI Act. And I thank you for your attention. Thanks.
Good morning from Brussels. Can you hear me?
Yes, we can hear you very well, Antoine Alexandre. Thank you for joining today. Do you want to share the presentation from your computer?
No, it's probably easier if you do it, and I just say next slide if you can do so.
Fine, thank you.
Okay, thanks.
Antoine Alexandre, thank you.
Thanks to you, and thanks for giving me this chance to present the AI Act and the very important role of AI standardizations in the regulatory approach proposed by the Commission. My name is Antoine Alexandre André. I'm part of DG Connect, and more specifically part of the unit in charge of developing AI policies in the EU. AI policies that we, the Commission, started working on back in 2018, and the creations of a high-level expert group on AI in order to discuss the issues that artificial intelligence technologies were and are still raising in terms of ethics. This high-level expert group worked closely with the DG Connect for almost 2 years and published a first set of ethics guidelines for AI in 2019. This first set was very welcomed by DG Connect, by the Commission, but it was felt after the work of the expert groups that guidelines were not enough, and that in order to ensure AI developments are going in the right direction, it would be important to have, in addition to these guidelines, a proper regulatory approach to AI technologies. In order to do that, we issued first a white paper on AI in February 2020, and then a first legislative proposal in April 2021. Please go back to the previous slides. Thanks. So now that I put a bit the context of the regulatory proposal that we published in April 2021, I would like to quickly come back to the regulatory visions that we have, and very much the double approach that we have taken from the start. First of all, I mean, it's important to keep in mind that we are very much in favor of AI technologies. AI is good for consumers. Consumers can get larger choices, new services, and potentially higher quality of life. AI is obviously good for businesses. It gives lots of business opportunities for companies that are keen in investing in these new technological areas. And finally, AI is also good for the common good, as there are many public interests which can be much better pursued with the help of artificial intelligence technologies. For instance, the fight against climate change or the better allocations of public services, just to name 2 different examples. But the AI technologies creates also major risks major risks for what concerns privacy, for what concerns discriminations, for what concerns safety. You can think, for instance, of self-driving cars or self-driving fly, and it creates lots of risk also to fundamental rights. Next slide, please. And it's given this double approach that we published, as I already mentioned, in April 2021, what we like to call the AI package. The AI package, which is composed of first a communication, which explains our approach to AI development. Second, a revised coordinating plan, aiming at accelerating investments in AI and aligning the different AI national policies to avoid fragmentations in Europe in the internal market. And third, the proper proposal for regulations of AI, i.e. the AI Act. Next slide, please. The AI Act is, just to give a bit of background, the AI Act is a classical product safety legislation laying down uniform rules, complementing existing EU and national law in order to create a single market for trustworthy AI and address the risk to safety and fundamental rights. This proposed regulations aims at first providing certainty to our operator and stimulates trust in AI and trust in the market. Once again, this is really in line with the double approach explained earlier. We want, on the one hand, to foster innovation, while on the other hand, protecting against a potential risk. The approach chosen by the Commission would require all companies providing AI systems to European citizens to comply with the AI, to comply with the requirements as highlighted in the Act, not just European companies. All companies providing AI systems or using AI systems on European citizens. Next slide, please. So, as you are probably all aware of, the AI Act proposed a risk-based approach. So it's very important to understand that for a large majority of AI systems, the AI Act do not foresee any obligations. This is the part in green on the pyramids displayed on the screen. Then, for AI systems interacting with humans, such as chatbots, informations and transparency requirements are proposed. Then you go one step higher. For those clearly defined AI systems that pose high risk to safety and fundamental rights, the AI Act proposal introduces specific, also clearly defined requirements. And then, finally, on the top of the pyramid, the proposal of the Commission prohibits certain practices that contravene EU values, such as social scoring systems by public authorities or the use of real-time remote biometric identification systems for law enforcement purposes in publicly accessible space. Next slide, please. So, as mentioned earlier, the Act as it stands has been proposed by the European Commission, by DG Connect. This does not mean that the AI Act will be published as such. For the last 2 years, the co-legislator, namely the European Parliament and the Council, have been working on the file. The Council is the first co-legislators to have adopted its position on the AI Act proposal. It adopts its general approach on the 6th of December last year. It is important to highlight that the compromise text of the Councils largely preserve the overall architectures of the Commission's proposal, with some specific additions and also extensions of the period foreseen to adopt specific rules for what concerns general purpose AI. So tools just like ChatGPT or others that we are currently seeing a lot in the news. In the European Parliament, the lead co-rapporteur published their first joint draft report already on the 21st of April 2022. Then more than 3,300 amendments were published to the plenary in June 2022. And when initially the European Parliament plenary vote was scheduled for the end of 2022, the emergence of numerous debates, new debates, notably on for what concerns general purpose AI, slowed down the proceedings. Now I arrive here with good news. The committees in charge of the AI Act, so the IMCO and LIBE committees, just adopted last week their positions on the AI Act, and now a plenary vote in the European Parliament is foreseen by end of June 2023. Trilogues would then be held mostly under the Spanish and probably a bit also of the Belgian presidency. Nevertheless, it is worth deeply mentioning that, deeply informing you that the co-legislators committed to the idea of concluding the discussions on this very important file before the end of the European Parliament's mandate, so before the end of spring 2024. Next slide, please. Now, entering a bit into the mechanisms of the proposed legislations, the proposed AI Act is structured as what we called a new legislative framework type legislation, NLF as we call it. NLF is a well-experimented regulatory schemes that provide high-level provisions and essential requirements in the main legal act, so in the AI Act, while economic actors can achieve compliance with these requirements through the use of either harmonized standards or other technical specifications, or can be developed in accordance with general engineering or scientific knowledge. It is important to note, especially for you in the aviation sector, that for what concerns sectoral legislations under Annex 2, Section B of the AI Act, so specifically for aviation, the AI Act does not directly apply per se. But the requirements stated in the AI Act would ultimately apply in the future when existing sectoral rules will be amended. So it's still important to understand and start to take part in the discussions on the requirements of the proposed AI Act. Next slide, please. The objective of these types of legislative framework, the new legislative framework, is to help remove obstacles to free movements of goods in the internal markets and ensure that first, we don't need to adapt regulation too often to take into account technical progress. Second, we give flexibility to companies on how they want to comply with the requirements of the law. And third, we include industry in the rule decision-making process. It is really important to stress here and to understand that if adopted by a company, standards that will become harmonized standards would constitute a presumption of conformity with the relevant requirements proposed in the AI Act. So if these standards are adopted by a company, the company will be granted a presumption of conformity. And that's why developing standards that will become EU harmonized standards is key to help companies comply with the future AI Act as it will be adopted by the co-legislator. Next slide, please. So as explained, harmonized standards will have to be produced to operationalize requirements which are stated in the AI Act. Standards play there a very, very important role. Now, the approach taken in the AI Act is what we call a horizontal approach, meaning that horizontal standards would need to be developed. That does not mean that sector specificities do not exist. That does not mean that for aviation, for instance, sector specificities does not exist. But this means that we ask, notably through European standardization requests, we ask European standardization organization to start developing standards that would be horizontal and would serve as a basis for standardization developments in all the different specific sectors. Now, requirements on which we will ask European Standardization Organization to work on are displayed on the screen. They are part of a standardization request that we are just about to publish. And they cover training, validation, testing of data, technical documentation, logging capabilities, transparency, information to users, human oversight, robustness, accuracy, cybersecurity, risk management, and finally, conformity assessments. Now, we know that the aviation sectors has been working on certain of the requirements we developed in the EASA Act for quite a long time now. We are in contact with EASA, with EuroCAE and others, and we really see aviation as a very, very interesting case study for us and for the AI standardization community, which is starting to develop these horizontal standards. We are really keen on learning from what you have been doing so far, or from learning from the discussions you have been having, from learning from the frameworks you have been put in place, such as the one you will be presenting today. Next slide, please. Our ultimate goal is to have a set of European harmonized standards available 3 to 6 months before the dates of applications of the AI Act. We, the Commissions, are currently involved in standardization activities, and we are currently mostly involved in first mapping the relevant standardization activities currently being developed at horizontal or at sectoral level. Secondly, participating in strategic standardization activities, notably in the Joint Technical Committee on Artificial Intelligence, which has been created at European level, but also the Special Committee on Artificial Intelligence, which has been created at international level. We are also providing political, legal, and operational support to the European standardization organizations for what concerns the interpretations of the Act. Now, as I just mentioned, we are just about to publish the formal standardization request, which highlights standardization needs of the AI Act and which is directly sent to European standardization organizations. It is worth also noting that given the socio-technical particularities of AI technologies, we have pushed and we are continuing to push for AI to be used as some sort of test case to increase the involvement of civil society representatives and larger mobilizations of different kinds of stakeholders and experts in AI standardization activities. Next slide, please. Now, among the most important elements that are part of the standardization request that we are just about to publish, there are first the timeline. As I mentioned earlier, we want to have these standards ready more or less 3 to 6 months before the end of the transition period of the AI Act, which would mean that we ask the European standardization organizations to have standardization deliverables ready by 30 April 2025, which give us a very short time to develop these standards. Second important part of the standardization request is the fact that we address the request specifically to Sensenelec and specifically to this joint technical committee, which is working on artificial intelligence, but that we stress that ETSI's involvement is very important and that ETSI's involvement should particularly be taken into ETSIS should be particularly involved in standardization activities for what concerns AI security. Third, we also another element which is important to highlight is the fact that we explicitly reference the importance to involve relevant stakeholders, including SMEs, societal stakeholder, and also sector-specific stakeholders, which have been developing AI standardization already in the past. Fourth, we also explicitly mention the need to make sure that fundamental rights and data protections are well taken into account. And last but not least, we also explicitly mention the fact, the importance of using existing international standards to the maximum extent possible. This, however, should not be bring any prejudice to the full alignment of European developed standardization deliverables with European values or European specificities. Next slide, please. So now I remain entirely at your disposal, if not now, then in the future, to reply to all the questions you might have on the Act or on the standardization activities. You can find my email on the screen. And I really do, I'm really looking forward now also to hear from you, from the aviation sectors, to learn what you have been working on so far, to make sure that we create links between what you have been doing so far and what we intend to push as horizontal European standardization activities.
Thank you, Antoine Alexandre.
So yes, indeed, thank you, Antoine Alexandre, for that good overview of the regulatory approach in this area. Our final keynote is also going to be delivered remotely. Dr. Nicholas Asher from Aditi is a specialist in natural language processing, reasoning, and the formal modeling of semantics and pragmatics of natural languages. He's speaking to us today about AI trustworthiness. Over to you, Nicholas. Nicholas, we don't hear you. I always wanted to be a TV anchor. So it seems we have a problem with the sound. Do we need to switch off here?
I don't think so, but
Sorry about that.
now it's working, yeah. Thank you.
Yes, okay, thank you very much. Guillaume, maybe you can also just do the slides for me.
Sure, my pleasure. The floor is yours, Nicholas. Thank you.
Okay, so thank you very much for inviting me to speak here. I am the director of ANITI, which is one of 4 of the interdisciplinary AI institutes in France. We're located in Toulouse. We're the Artificial and Natural Intelligence Toulouse Institute. And I've also been working with Guillaume and the rest of the AI committee in EASA for the past year. And I'd like to share with you some of my thoughts on AI. Okay, next slide, please, Guillaume. Okay, so just a little bit of background on artificial intelligence. You all know what it is, sort of, but it's more of a family resemblance notion. That's what philosophers call it. It doesn't have really a strict definition. It pools together various activities that we think are marks of intelligence. And I'm going to, several, of course, are very important to aviation. And actually, one of ANITI's main application areas is intelligent mobility, in particular, aerospace mobility. Okay, so a couple of areas. Madame Daschler has already mentioned several areas where AI can affect the aviation industry, ATM, maintenance, and so on. And I'm going to talk about a couple of these that are where we have a little bit more challenges, like conversation and planning and scheduling. And you all know that AI is a huge growth area right now, and the latest breakthroughs in the large language model arena have made everybody very excited. And so there's a lot of potential there, but as both Antoine Alexandre and Madame Daschler have said, there are also risks. And AI solutions in aviation, we feel at ANITI, are only going to be possible with an adequate level of trust from operators and the impacted public, which are the passengers. Next slide, please. So what we've been looking at in our group at EASA are 2 levels of AI involvement. Level of 1 you've already heard about, which is where artificial intelligence just assists humans. And we're looking now at a level 2, where we really are thinking much more in terms of a human-machine collaboration. And that's something that's going on in ANITI too. So there are 2 levels. One has to do with cooperation, where the human retains full authority and actively monitors all the tasks. Here, communication is not paramount. It's more of a directive product, and the human is in charge of the goal. When we move to a level 2B, things get more exciting and more complicated, because the human now has partial authority and is actively monitoring still, but is has a shared goal with the AI system. And the 2 are supposed to work together. And here, communication becomes paramount, where you're sharing both ideas and awareness of the situation. Okay, next slide, Guillaume. So how are we going to then think about trustworthiness in these complicated scenarios? Well, one has to do with the technical objectives, and Madame Daschler talked a little bit about this, how we need to know what the system does and how well it does it. Ideally, what we need here are mathematical proofs, or logical proofs. Perhaps we can only get statistical bounds, but we need to have rigorous ways of establishing those statistical bounds on the way the system is working. And that is a big issue in current AI still. There are also human-centric objectives. So as we move towards this level 2 of AI integration, human-system interactions are going to have to really take a center seat. So we have to think about how the system can optimally interact with human operators, both, let's say, in the cockpit, but also in ground for ATM operations. Then finally, there's this this third aspect of trustworthiness, which is very important, and Antoine and Alexandre told us quite a bit about this from the regulatory side, which is this ethical and liability issues that come up with putting an AI system in an operation or a larger system in which perhaps a lot of money is at stake, or more importantly, human lives. Okay, and we need to make these kinds of ethical and liability issues clear enough to the end users so that they have confidence in the system. Okay, next slide. Okay, I see three very important challenges for trustable AI at this level too. There are many others, of course. One concerns these guarantees of performance and also the robustness of the system. So we want the system to be able to act in ways that ideally a trained human would expect it to act. It shouldn't give strange results for slight perturbations in the data that would not worry a trained human operator. Linked to robustness is also this notion of interpretability or explainability. This is something that concerns us a lot in INET. It's a controversial issue, but we think that the interpretability of the system is key for trust. That is, we have to be able to explain to users, like the pilot or controller, the behavior of the system. Finally, the system may need to explain itself to the pilot or the controller in an online way. So this is a very ambitious goal and a big challenge. Finally, trustful AI at this level 2 is going to require fluid and secure interactions between an AI system and a human. And as all of you have seen from articles in the newspapers and reports on television and so on and on the web, the new level of large language models do offer fluid conversational abilities, at least for short exchanges. Are they secure? Well, that's a question that I'll come back to in just a minute. Next slide, Guillaume. Okay, so let me first take a closer look at explainability and interpretability. So what do I mean by that? I mean that if the AI system provides a prediction, say for maintenance or for traffic avoidance or any of the myriad applications that we envision, we should be able to get an answer that satisfies the user. So there's a pragmatic component here where we want the explanation to be satisfying to the user, but we also want the explanation to be correct. And now, what do I mean by that? An explanation will be correct. That is, if I explain this prediction P by this series of clauses E, then whenever E holds, we should expect P to also hold. Okay. Now, the strongest kinds of guarantees we can get from that come from symbolic formalization. Okay, so deep learning devices are still, Turing machines, and we've known for over 60 years that every Turing machine has a logical theory. So we can translate the entire model into logic, give the input in terms of logical clauses as well, and then derive the predictions. When we can do that, we have the strongest kind of interpretability, the strongest kind of provable guarantees on the behavior of the system that we can get. But this is difficult, if not impossible, to extend to large deep learning models. So we have a hard limit there. There are many statistical methods for interpreting behavior out there. but even they run into challenges with the latest kinds of models that animate the large learning models, the so-called transformer architectures. And that's because of the way the transformer architectures compute the latent representations of their input. And so that's a very active area of research, but there's still challenges there. One way of bridging the statistical and the symbolic formalization methods has to do with so-called counterfactual models, which are logic in principle, but they don't have the absolutely strong guarantee of a deduction. They have something slightly weaker. But they do generalize to larger deep learning models. And that is also an area of exciting research. So if we can get these kinds of models to work and to work in real time, then what we can have is an AI system that is interpretable and can give user-friendly and user-satisfying explanations. Okay, next slide, please. Okay, so then one other sort of quick zoom in on issues. So let's look a little bit more at conversational assistants and cobots. These could be of immense value, say, on the assembly line or in predictive maintenance. And we've had massive progress in the last year using these transformer architectures, going first from GPT-2, which wasn't all that exciting, GPT-3, which started to do some things, then we got ChatGPT, and now we have GPT-4, and they really have very fluid conversational capacities, and they are adaptable to many natural language processing tasks. But they do have certain problems that we're just beginning to understand. They have troubles sometimes with reasoning, and they do something that what people call hallucinate. That is, when they don't know an answer, they make stuff up. So, and I think you've all had experience on this. On the other hand, these models, actually the GPT models, have the drawback also of being closed models. So we don't have access to their training data. We don't have access to the mathematical values of the various levels of processing in the machine, and we don't really have access to their training. So that makes it very difficult to talk about them, and they are learning as people interact with them, so it makes them a moving target. Nevertheless, we need to solve these problems if we're going to use these kinds of architectures in safety critical operations. So, and fixing these problems is not easy. Sorry, but we know a lot more about these models than we did, and we're experimenting with different ways of training them and of also embedding these models in a multimodal framework. That is where we pair language with vision and maybe also even proprioception information, touch, to further constrain the large language model. Next slide. Okay, so I've just given you two very, high-level overviews of two very active areas in AI research that I think are important for the aviation community. But there are lots of others. So here in INET, I'm giving you just a quick overview of the various issues that we deal with. In certifiable AI, which is clearly geared towards the aviation industry, we're working on safe design and embeddability, optimization, how AI can be used with physical problems, physical processes, so modeling physical models. We're also looking at things in acceptable AI, like explainability, as I've just talked about, learning with complex data. And finally, in collaborative AI, we have an active area of research on language that also interacts with robotics and also neuroscience. And finally, predictive maintenance is an active area when we're looking at data and anomalies. So now I'll just close, Guillaume, with the people in ANITI on the last slide. And that's all from me, and thank you for listening. And I look forward to your questions during the question and answer period. And ANITI has its website, so we welcome you to come look at the website and also contact us, and we're happy to talk to you more. Thank you very much.
Thank you very much, Nicolas. Thanks.
Thank you, Nicholas. Now, Nicholas touched there on question and answer session. We're going to do that after the next session of comments and presentations from our EASA AI experts. But I just wanted to share the information on this slide with you now before we go into the break. We'll be taking all questions through the Slido tool. Slido, you go to slido.com, and then you'll need to put in the hashtag AI Days, which is there, and the passcode, which is AWRT0L, all in small letters. So AWRT0L, all in small letters. We had some interesting challenges trying to put this across in a font that you'll be able to read. So that's okay. So we're now going to break until 10:45. So can the people who are in Cologne please be back in the room at 10:45, and everybody online enjoy your break as well. Thank you. Okay, we've just got the last people coming into the room here now in Cologne, and we're getting ready to start up again for our next session. So we're now going to move to the roadmap itself. People in Cologne have a copy on their desks. People at home can find it online. And we have two sessions now from our experts at EASA to actually look specifically at this. So first of all, you'll hear from Guillaume Soudin, who's standing right next to me and who I'm sure most of you know is the manager for our AI program here at EASA. After that, our chief engineer, Alain Leroy, will share his views on the AI deployment timeline. Directly after that, we'll go into the Q&A session. Just to mention again, we're using Slido for the Q&A. To be quite clear on that, that means there's no microphone in the room, and you can't put anything into the WebEx chat if you're joining us from some other location. So it all has to go through Slido. The hashtag is AI Days, and the passcode is AWRT0L. So if you get online now, you can start to ask your questions actually as we're going through the session. So at this stage, I hand over to Guillaume.
Thank you very much, Janet, and welcome back here. Very glad to see numerous people here. Online, we have a huge participation as well, so very glad to have all of you today. So I would like to warmly thank Rachel and all our keynote speakers. After these inspiring talks, which have set the scene very well, I'm pleased to now start unveiling the EASA AI Roadmap 2.0. In the next 30 minutes, I will drive you through the most important aspects of this new version. So here it is. So you can see it online, but also physically you have a copy of it. That's a great achievement, I would say, from the EASA program team, that there is a big team behind me working on that, and a lot of support from EASA management, so I really thank everyone. So to drive the journey through the presentation, I've prepared the following Ariadne thread. So first, we will look back at the EASA AI program activity and the steps we undertook so far. Secondly, we will rescope the roadmap to cover a wide range of AI techniques. This section will explore the different types of AI technologies and applications, from data-driven to knowledge-based AI through hybrid techniques. And we will also discuss the implications of these techniques for the next releases of the EASA concept paper. Thirdly, we will deep dive into the different facets of the AI trustworthiness concept that was laid down and explained in an overview by Nicolas Ascher in the previous keynote speak. This section will explore the various dimensions of trustworthiness and discuss how they relate to AI in aviation. We will also explore the challenges of ensuring trustworthiness in the development and deployment of AI technologies. And lastly, we will look forward and present the updated list of priorities for the EASA AI program. I hope that the presentation will be both informative and engaging, and look forward also to your questions in the Q&A session, so don't hesitate to use the Slido for parking your questions. So let's start first with an overview of the EASA AI program. So you can see here on this slide, it's composed of a steering committee, the ESC, so the EASA Safety Committee, and then I have the honor to be a program manager for this activity. And then we have a huge team, I would say a core team that provides most of the effort in terms of management of the necessary resources to get to publish what we call the deliverables of the AI roadmap, so the concept papers, but also working on IPCs, innovation partnership contracts, and research projects. So the core team is here, oriented by 5 project streams. The three first are actually about the guidance development, so advanced AI, assurance, safety, and cybersecurity, led by François Triboulet with Xavier Henriquel as technical lead. The human factors for AI and explainability, led by René Pelchin-Medved and Mathilde, here in the room is technical lead. Ethics-based assessment is led by Ines, who also provided a huge support to organize the conference, so I really thank her warmly. And Axel, also, who is with us today as a tech lead. So those 3 first projects are, let's say, the core part of the guidance development. And then we have aggregated all the use cases that we encountered. We have a number of them through various ways, IPCs, research, certification projects already. And they are the project is led by Giovanni Shima, and François is also a tech lead. Both of them are with us today. And this project has really a top level that you can see here, but is kind of a huge iceberg below with all the use cases we have engaged with so far, and we get a lot of solicitation to get into other use cases. The AI demonstrator, led by Léopold Viroles from Data for Safety, is Program Manager Data for Safety, and Yvan Delepinay is Tech Lead from the Sustainable Aviation Program. So here, the AI demonstrator is an ambition to liaise, I would say, between 3 programs, the AI, of course, Data for Safety, and Sustainable Aviation, in order to find a common ground to see the potential of usage of AI in such applications that will be good for aviation sustainability. All these people are interacting with a network of experts and the scientific committee of EASA, and this is the place where we have also resources, additional resources, to develop, but also test and check and review and I would say challenge the guidance we are developing. External stakeholders interaction is key, of course, through memorandum of understanding, research and innovation or certification projects, and it's very, very important for us to have the feedback from everyone. That's why also we have this strategy of getting for consultation on each each deliverable of the roadmap, which become public when we go on. From there, we have the roadmap has delivered several key milestones and deliverables so far. So the initial roadmap was published in February 2020. It was the first major deliverable, of course, of the project at that time, which has become now a program, outlining the agency's approach to addressing the challenges and opportunities presented by the integration of AI into aviation. The first concept paper was then published in April 2021 for public consultation, providing a comprehensive overview of the anticipated guidance and objectives related to the certification or approval of AI into safety-related or safety-critical applications. That's very important to put this as a focus of work. And this was followed by the release of a consolidated issue 1 of the concept paper in December 2021, which incorporated feedback received during the public consultation period. Then in February, not forgetting, we have also published the first EASA special condition, as was mentioned by Rachel Deschler, in order to call this first concept paper into a CRI, a certification review item, actually a special condition CRI, that we can deploy then concretely in projects. In February 2023, at the beginning of the year, this year, EASA published a subsequent issue of the concept paper for consultation, the proposed issue 2, which further refined the guidance based on additional use cases we got with the notion of human AI teaming that was underlined in the previous presentations. In parallel to these key publications, the EASA program has also released a number of important deliverables jointly with industry stakeholders. So you can see the CODAN reports, which we performed jointly and together with Daedalin. Luc will talk about it shortly this afternoon when presenting use cases from Daedalin. The Formula IPC report, more recently, was published a month ago. It was a work done in collaboration with Collins Aerospace ART in Italy, focusing really on the use of formal methods for learning assurance aspects. And we have published last week, jointly or at the same, synchronously, I would say, with the EASA AI Roadmap 2.0, the MLIP public report number 1, which is the first public, I would say, outline of what the MLIP project is doing. And you will hear a lot more about it tomorrow in the MLIP Stakeholders Day, sorry. All of that led, of course, to this Roadmap 2.0, and I'm glad to unveil it today in a lot more details. So to start with the roadmap, we have to think in terms of scope, technical scope. Here on the slide, you can see the current scope of the Roadmap 1.0, I mean the previous scope that was laid down by Roadmap 1.0. We are focusing a lot on machine learning and deep learning because that's the solutions that were brought by our applicants first, I would say. Now we are considering under the umbrella still of AI, and needless to mention, we have updated the definition of artificial intelligence to better stick to the proposed EU AI Act, a definition that we had one that was already quite large, but actually was focusing on the notion of cognitive performance of a human, and we see a lot more applications that are connected to that, but not necessarily directly focusing on that. So the human centric aspect is still there because it's about human-defined objectives, but it's a technology that can generate outputs such as content, predictions, recommendations, or decisions influencing the environment they interact with, which gives a large umbrella. We don't try to, let's say we address AI at large, but then we focus on specific technology, techniques, in particular, again, machine learning, deep learning so far, and we see more and more logic and knowledge base, so-called symbolic AI approaches coming our way with either expert systems being revived or the logic of, let's say, using these techniques of symbolic AI in order to create a rule, a knowledge base, and be, I would say, a bit more, a bit less statistical or stochastic than what machine learning is bringing. Statistical approaches are also still an important, let's say, third approach that is developed in the EU AI Act. We shouldn't forget about that. And the very important thing to say is we go for hybrid AI as a definition of any hybridization of those techniques, of those three big blocks, in particular, for instance, neurosymbolic reasoning, which goes along the line of using machine learning for what it's best at, like perception aspects, and using logic, knowledge-based approaches to kind of encapsulate it in a decision model that would be a bit more, let's call it deterministic, if we may use this word for that. So that's a very important thing. The scope of technology is evolving in the roadmap. And now let's deep dive in the AI trustworthiness concepts. So they are underlying in the whole roadmap for sure, but they are more developed concretely in the concept paper, in the AI concept papers. Let's start again from the challenges. You heard about them from the different presentations this morning. The ones we have in the roadmap are oriented by 4 big categories: data management, AI model assurance, AI explainability, human AI teaming. Not saying it's the only challenges, but that's the main ones we have focused on to develop the guidance so far. Yes? Oh, yeah. Okay, I hope you hear me better now on the WebEx. Okay, on the data management side, development assurance frameworks are not adapted to learning and inference approaches. That's something we recognize from the issue 1 of the concept paper. Therefore, we complemented this view. You will see a bit more in the concept I will develop in a minute. Difficulty in keeping a comprehensive specification when you hit data or knowledge management. Then on the AI model assurance, addressing model bias and variance optimization in the various steps of the AI assurance process is a key. Elaborating also pertinent guarantees for the AI models. And we know that some of them are very tough to reach. That's why we also started the MLIP research project. AI explainability, coping with the limits in predictability and explainability. That's something that was touched upon by Nicolas Asher. I will not go in more details. He did it very well. And the human AI teaming is a bit the new player in the concept paper level 2. You could see that we developed these 2A, 2B levels, and it's about, from the top level challenges, managing shared operational authority in novel types of human AI interaction, and dealing also with adaptivity on the AI application. And the response to that from an EASA perspective is this AI trustworthiness concept. So I will drive you now through the important aspects of the concept. Anyway, the first concept definitely is this classification, leveling of AI applications. So level 1, level 2, level 3. Level 1 is about cognitive human assistance, level 2 human AI teaming, and level 3 advanced automation. These are the 3 levels that are orienting, I would say, the structuration of the work we are doing so far, and helping us also interacting with stakeholders. And at last will also serve as a proportionality means. We know that proportionality will be not oriented only by the criticality of applications, but also by these concepts of interaction, level of interaction, or nature of the type of interaction between the human and the machine. At level 1, we've already developed in the concept paper level 1 this notion of W-shaped cycle, so the adaptation of development assurance frameworks as we know them today to learning, machine learning and deep learning approaches. We've developed also AI explainability as a concept that has 2 views. One focused really on the operation itself. So the operational explainability is really about the end user needs in terms of explainability at the time of operation, but we see also that there is an explainability in development that is key in order to open, let's say, the transparency on this so-called AI black box at the time of the development. Continuous safety risk mitigation. I will come a bit more in details on it on the next slide. It's a very important concept to deal with innovative solutions, being able to feedback from an operational view the level of, let's say, of feedback that we can get from operations on the assumptions that were taken at the time of development. That's a very important block. And then we have the ethics-based assessment, and that's a another very important aspect, and you will see in another slide how we can address it so far, and there is a lot of work in progress on this side. Now, if we look at level 2, what level 2 human AI teaming is bringing to us, Nicolas Asher has already showed the big picture here, and he made a very good, I would say, introduction to that. We have layered, let's say, the guidance in 2 pieces. On the one hand, the cooperation, level 2A, and that's where the machine goes through the human, who is completely monitoring in full control of the operation towards the goal set by himself, by the human, by him or herself. And then we have the collaboration, which is a novel way of thinking about interaction between humans and machine. If we think in a cockpit, but it can be also with air traffic controllers. The number of applications, I would say, is pretty infinite and can touch any domain. This is where the machine and the human share a goal and can work, I would say, a bit more in independence from each other for certain, let's say, steps of the operation, and work all together towards a shared goal. If we think a bit further, and that's really preliminary thinking here, what supervision could bring us at level 3. So level 3, we enter in an era where the machine would have a bit more authority, I would say a bit more independence in the nature of operation, yet the goals needs to be predefined from an operational perspective. And that's something we will see if we reach, I would say, a level of technology which is probably not here today to reach level 2B. We may enter level 3A a bit more easily in the sense that technology might support it. Yet there is a lot to do on the human factors side to manage supervision in a proper way. It's not an easy way of thinking in terms of operations. The last thing I wanted to show on level 3, and to be very clear, we have not developed anything on level 3. So it's a lot of preliminary thinking here, but in the conceptual way of thinking, we see also low-hanging fruits, I would say, coming on the side of advanced automation on level 3 with the 3B, meaning using AI at a time where the link to the human is not there anymore, whether because we've lost a data link with the US from a remote pilot perspective, or because there is an incapacitation of the human performing the operation. This is something where safety could be enhanced actually by using this type of advanced automation that would restrict the use case, and that's something that we are looking into and we will be looking into in the coming 2 years. From there is a perspective which we call autonomy, autonomous. Everyone is talking about it. Today in the roadmap and in the concept paper, we've brought or pushed this aspect a bit further in the roadmap by redefining autonomy. You will see a novel definition which we borrowed from the ISO standardization on AI. And this is something that pushes really and goes back to the roots. Auto means self, nomos means law. Some system that could give itself its own laws, and that's something that means own goals, probably, possibly set its usage domain. That's something that is really science fiction for us today. That's why we start thinking really in anticipation. That could be actually another level, let's call it 3C for now, and that's something we need to be very careful with, and that's what I represented here today. I didn't try to make any sketch of type of operations. This is a bit the deus ex machina that we had in ancient Greek theater. So when a problem is too complex to be solved, we bring with a crane a god on the scene, and that's a bit that's resonating a lot with a number of literature, movies that you could see as well. That's something to say, let's be careful and cautious when we make this step, and if we make this step. And in the roadmap, you will see in the presentation from Alain Leroy that it has been pushed also in terms of timeline ways beyond where we are today. Very last important thing on this slide, and that's an important one. I think it gathers a huge overview of what we are doing. We are doing it, again, in interaction with all stakeholders, with industry, with use cases. You can see the 3 ones that will be presented this afternoon. The Daedalin traffic detection and more are more on the level 1 side. Singapore, Samir from Singapore ATM-RI will show also applications in ATM on conflict detection and resolution and more that goes between, I would say, level 1B and probably into 2A. And then on the Honeywell side, Yuri will tell us about some anticipation on use cases that will bring us closer to the level 2B. So that makes it very concrete and down to the point in terms of testing of the guidance. I move rapidly to a number of zoom, I would say, on some of those concepts I was just outlining on the previous slide. The assurance concept, AI assurance, used to be called learning assurance. We've moved to AI assurance because of the extension of the scope of technology we want to tackle in the roadmap 2.0. To be clear, I will not represent the W-shaped cycle in all details. There is a lot to say. It's an adaptation, again, of development assurance to specificities of learning. We have data management to take into account, learning process management, model training, etc. And to make it very top level, we have 3 layers. We have the system level layer, where we try to augment the existing safety assessment and development assurance guidance. We have the novel part, which is the AI constituent level, with a set of objectives that are tailored to develop these specificities or specific guidance needed for AI. And AI, first machine learning, current scope of the concept paper, but tomorrow, symbolic AI, hybrid AI, we will expand the scope of this W shape. Let's see the shape that it takes. We will not invent a new letter, but let's see the shape it needs to take in order to expand this technical scope. At the bottom, very important to say, item level objectives are not meant to be let's say, reinvented. We don't reinvent the wheel there. We use existing software, hardware development assurance, guidance, standards to ensure an adequate implementation of the AI models resulting from the constituent level activities into an inference model. So that's a way, I would say, to take away the W shape and understand it maybe in a top level concept. Moving to the continuous safety assessment concept. It's a very important one. You will understand why. At the development phase, on the development phase side, there is no massive change in the principles. We still go for an initial safety assessment with based on the concept of operation, system definition, and all other inputs. It's setting the scene, I would say, for the safety objective that needs to be put on the application. Of course, it's a huge interface to the W-shaped process and all the AI assurance aspects that follow. And from there, we move to the operational phase, a model that has a number of assumptions. Of course, enough assumptions to be able to certify, approve, but possibly with a safety risk mitigation strategy, which I didn't mention, but it's a very important part. Yet, we may have a number of assumptions that needs to be verified in operations. And that's where we want to rely on data recording capabilities, monitoring capabilities, that will be extended beyond, I would say, what we are requesting today for a normal continuing airworthiness or type of operations, with a feedback loop, bringing us back to this development phase, with the possibility, I would say, to update the model, the application, to take into account some things that we would not have known, so the unknown unknowns, the uncertainty brought by AI technology. Moving to a last concept, very important as well, ethics-based assessment concept. We started, and that was high on the radar in our roadmap, from those ethical guidelines published by the EU Commission high-level group in 2018. We took this list of 7 gears. There are a number of items behind, and we tried to map these ethical-based items to the trustworthiness concept that we were developing with the AI trustworthiness building blocks in the roadmap and in the deliverables. Each objective has been linked to at least an item and vice versa, except a number of those which are, I would say, the core part of the ethics-based assessment, which are filtered out and it range from topics that you can see here on the slide. It requests somehow an ethics-based trustworthiness assessment to be performed. That's an objective. And then we have piled up a number of objectives linked to human attachment, adaptive learning, personal data privacy, unfair bias avoidance, environmental impact analysis and mitigation, competency gap, and risk of de-skilling. So you can see the plate is quite large. It's all topics that are, I would say, at the boundary of what we do on the technical side with the AI trustworthiness building blocks, yet it matters, at least for some of them directly for EASA. Some might be a bit at the verge or at the boundary of the remit of EASA, and that's something we take into account, knowing that additional oversight authorities might be necessary to oversee completely, I would say, an AI application. But that's all things we try to turn into guidance, based and linked on to organizations' requirements. That's something that will matter also, requirements specific for AI for organizations. And that's something we try to, that's work in progress, I would say. It's not the final call we have in the concept paper, but we try to provide visibility to EASA applicants, to not fear, I would say, to be kind of, we cannot approve because of ethics aspects. We take them into account from the start, and we try to give the right level of guidance to you in terms of visibility. And that's bringing me to the last part or slide in my presentation. So moving forward, we have an updated list of priorities. I think none of them will surprise you. There are a lot more. As challenges, we have a lot of priorities, but putting them a bit in a sequence in terms of importance, but also timeline. First, let's say a priority and urgent priority is, of course, to resolve the public consultation comments we received from the proposed issue 2 of the concept paper. Many thanks to all of you, all stakeholders who provided comments. We have a number to manage now. We will then publish the concept paper. We target towards the end of 2023. It will depend on, of course, the pace we can manage the comments, but I think we will be realistic with that. We will, of course, keep an eye on the certification and approval of first level 1 AI applications. Some are ongoing. And we will plan, in second priority, plan and execute the AI rulemaking concept. That's something that will be presented in all details by Michael Gerhardt later today. We will expand the W-shaped process to other learning techniques, taking into account also, that's the next line, guidance to knowledge-based and hybrid AI. So that's a huge expansion in scope, not to be underestimated. So that will take a lot of resource from the different project teams, that I showed you before. And we will, at last, augment the safety risk mitigation building block, which is a bit underdeveloped today, and anticipate the necessary and feasible guidance for level 3 AI. So there we have to take the time to mature what I have showed more conceptually today in the slides, to develop the right level of guidance and anticipate also the needs from industry, because that's what drives us. Today we are very well served, I would say, with level 1, level 2. We have a lot of challenges at level 2. Let's take a bit a break or a pause to think about level 3, yet we see applications coming, for instance, from the drone side rapidly, but also from other domains. Okay, that's all what I prepared for you. I hope you have a big picture of all what we are doing. We will dive into the timeline of the roadmap now with our chief engineer at EASA, Alain Leroy. And all the questions, we will take them at 11:30. Use the Slido, please. Thank you.
Bon, merci Guillaume. Good morning, everyone. So I'm very sorry. I have to walk you through a lot of timelines, dates. And of course, you could imagine that what you have in Roadmap 2.0 is a subset of 1.0. But if I tell you that timelines which were developed, how far ago? 4 or 5 years, have been all abided by, you will not trust me. So you will see that we move a few of them to the right, and we have good reasons for. But anyway, here what we have is a change from a first roadmap to a second one, which is a pragmatic approach, a realistic approach to what we have learned together. We have to be humble. We have to be modest here. We like to be optimistic. We like to develop ideas, concepts, but at the end of the day, we have to make sure that as a regulator, as a safety regulator, we are safely working all together, and we ensure the public a safe journey toward 2050. Merci, Guillaume. Yes, that's better. So that's me a few years ago. So if you look at the difference, or if you go through, I will not walk you through because I think it will be done later on, and Michael Gerhardt will have the pleasure to have a real insight on the rulemaking program. You will see that we have adapted our views to the industry prognostics. We had some assumptions years ago. The assumptions were all fine, all good in 2019, 2018, but we have learned, we have seen that we have a lot of challenges, opportunities, of course. Any challenge is an opportunity. And what we have done here is, in a realistic way, readjusted our way to work with you all. You will see that the notion of partnership is developed all along the presentation, and this is very important. So, in a nutshell, what to remember from this, before seeing all of the timelines I will bombard you through, is a pragmatic, realistic approach to challenges we are enthusiastic to tackle with you all. So, that's what we had some time ago. That's the original roadmap point 1. We had 3 phases, and of course the most challenging one is still to be fully explored at phase 3. But before going to phase 3, let's come back to what we did before. So we believe that this way to structure the work in 3 phases, phase 1 to really explore the first guidance, phase 2 to start framing something, and phase 3, we will see later, to push the barriers, is offering us the necessary flexibility. You cannot talk about innovation, you cannot talk about disruptive topics without having a flexible approach to your job. However, that's coming back to the management approach. We have to make sure this is properly framed and planned. So, what has happened? We believe it was efficient. It was a nice way for the team, the program team led by Guillaume, to work and to develop with you all those first guidance. And we have now to enter into what we call phase 2. Phase 2 is what you see here in red. Guillaume and his team developed phase 1 until last year, which was to our satisfaction, and I hope to your satisfaction, delivering results as per the planning, sometimes with a few surprises in the journey. Guillaume, I think you can confirm. But overall, I think we all achieved a good work, and I hope we can agree that the next challenge, come on, I need to click, oh oui. I'm so used to have this automatic, sorry for this. So, so yes, this was the roadmap point 1, and now where we are is, sorry for this, is with the unveil of the roadmap 2.0, we have moved a few deadlines, but extremely important, extremely strategic, to the right. We were a bit, let's say, over-optimistic or enthusiastic with roadmap point 1. I will not call back what we had for the first level point 2 and for the level 3 AI guidance, but I think we gave it a try. We all learned with industry partners, with institutes, with research institutes, with academias, and what we learned is that the challenges are a bit more complex than what we had in mind initially. And again, as a regulator, we have to remember that we are always targeting a safety level at least as good as today, and even better. This is very important. In particular, when we move to higher level of automation, not to say autonomy, but already automation. And when I speak about safety level, I should also talk about sustainability. EP, environmental protection, is also something we have to bear in mind permanently, when we develop new topics. So that's in a nutshell what we have here. The changes in the roadmap in terms of timeline, as you see, are mainly here. The 2035 and the 2050 for, let's say, autonomous system. And when I say autonomous, I mean autonomous, under Guillaume's control. We have a lot of internal discussion on what is automation and what is autonomy, and how to transit from automation to autonomy. So this 2050 is really targeting autonomous system able to make decisions. And of course, the challenges are huge, and of course, opportunities are even bigger. But before talking about opportunities, unfortunately or fortunately, we have to talk about the work to be done, Guillaume. So let's move this time. I click. This is what we have, 2035 for level 2 and 2050 for autonomous system. So that's the new vision, that's the new timelines. We have a few more years than what we were expecting initially, but we learned by doing. We have identified the challenges. I think Guillaume and the other speakers before started to introduce those challenges, to touch a bit about them, and we will have the next 10 years to work with you on this kind of interesting matter. So now I move back to the, sorry, I have a small problem, to what the team did so far, up to now. Phase 1, Phase 2, the first roadmap 1.0. I will not walk you through again all of those deliverables. What is important, I would like to stress, is the upper part versus lower part, if I may say. Upper part is our internal work, the regulatory work. Lower part is what we do with industry, with partners. Sorry, Guillaume? So in the lower part, what we have here is a number of stakeholder prognostics, a number of activities with stakeholders, and at the end of the day, 2050 now is what we're targeting for. So Guillaume, again, thanks. You have here the first deliverables, 2021, good. Or 2023, let's be honest. We plan 2022, so no problem. I think we are on the safe way here. So, now Guillaume, maybe you want to walk us later on onto this 2025 guidance on level 3 AI. Maybe I would like, it's a surprise to you, to give you the floor here just to introduce the small difference we have made. Guillaume, please.
Yes, thanks, Alain. No, this slide is really about, let's say, understanding that we've kept a certain timeline from 2021 to 2023. Now that we enter with all the challenges that I showed just before on level 3, we are pushing 1 year of the timeline, let's say, that was initially foreseen, which I think is absolutely was anticipated from the start. But that's really to take also the time entering there, probably entering into, as I said, level 3A, 3B as a start, and seeing where we push this notion of autonomy further. And about autonomy, you will hear a lot this afternoon with the panel session of discussion on the topic. Thanks, Alain.
Good, thank you. So that was important to clarify, because that's one of the core decisions we made in the agency here. So, as we said before, today and for the next couple of years, we are in the consolidation phase, extremely important. The notion of pause, the notion of slowing down is frequently seen as being negative. It is not at all negative. We are here learning by doing. We are developing our technical knowledge together with you. And most important, we capitalize on all what has been done. And this Roadmap 1.0, those IPC, those collaboration agreement, plus the Roadmap team work, there is so much to digest, there is so much to put in good shape that now it is time to have this consolidation. So this kind of pause, this kind of delay we introduce has nothing wrong. To the contrary, it means we are aware, collectively, we are aware of the challenges and the opportunities. And it is very important, before rushing or racing for more automation, to consolidate what we have done. And that's what you can see here. So 2026 and 2025 before are the new deadlines we are having here. So nothing really surprising to you. 2026, that means 2.5 years from today, we finalize all the guidance on level 1 and level 2, AI and machine learning. It is already quite a lot. If we have this, I think you, all stakeholders, industry, operators, ATM community, you can do a lot. And in the meantime, Guillaume and his team, they will continue, of course, to work on many more challenges. And 2028, so a bit later, we finalize the guidance for level 3, AI machine learning. This, I think, Guillaume, is quite a challenge. Are you ready? Absolutely. Good. I was sure he would say yes, so no doubt about it. So to summarize, 2026, the finalized guidance level 1 and level 2, and 2028, the finalized guidance for level 3. This is a challenge. We will have to work with all of you in good harmony, in good pace, in good coordination, I would say, but we are sure that together we can succeed. So this is the full plan. 2029, adapt further to innovation for AI. This is the long-term objective. I'm pretty sure we will have many more workshops in the meantime. I'm pretty sure that we will have some adjustment, but at the end of the day, what we will have is a set of material, a set of guidance, a set of regulatory material, very important, developed together with you, consistent, as we mentioned this morning, with the AI Act, very important, not to have parallel activities, in coordination with the standard organizations to make sure that you can use whatever is necessary for you to work. And in the end, again, as a regulator, safety regulator, we will ensure that our journey is safe and sustainable. So, I stop now because timelines are really boring. Sorry for this, just before the break. I hope it was still clear to you. What is important to remember? That all of the work we do today is to remain consistent with the 5 high-level objectives. I will not go through them all in detail, but just for you to remember, the first one is, of course, our credo, if I may say, or our leading sentence. We have to still develop a human-centric AI trustworthiness framework. Extremely important. We do not want to innovate here. So that's the driving line, or the red line, let's say, and I'm pretty sure that all together we will make it happen. Of course, this has to be done considering the other activities below, the other objectives. At the end of the day, what we want is to contribute to the leadership of the EU industry. let's say, or to the well-being, to the wealth of the EU industry in this domain, to be on the leading edge of the innovative development in AI. That's what we have in mind. It's a legitimate objective. I think we are well placed for it. And if we work together, again, partnership, you will see later, we have a good chance to achieve it. So, engaging with all stakeholders. Engaging. So it is simply what we call the partnership definition or concept pushed to the extreme. Partnership, we are having more and more notion of partnership, collaboration agreement, etc. in the agency, because we cannot work in isolation. We have to work with you. We have to ensure that we develop the right knowledge. We work with all industry stakeholders, but also the public. We have to get the public buy-in. Extremely important. So what we will do with you, with the advisory bodies, with industry, meaning all industry sectors, is to ensure that we can have a common message, a common vision that we can share with the public, and that we can really show this is safe and sustainable. This is extremely important. Extremely important as well, and you saw before, we have to work with all regulators and with academia, research institutes and other partners. Without them, no chance. And Eurocase is in the room, of course, standardization bodies. We need you. If not, we will never achieve what we have in mind. So, partnership, important to achieve the objective number one, which was the safe, trustworthy AI framework. Alors, now comes the interesting question. What about autonomous operation? I think we alluded a bit before what we called level 3C, Guillaume, in your presentation. And level 3C is a bit of a dream today. But we do not innovate without dreaming, because if we don't have any dream, we make no progress. So this is the long-term vision. This full autonomy is heavily discussed, heavily debated all over the world. There are a lot of ethical, a lot of other barriers, a lot of other challenges to be developed. But what we have in mind here is to put a complete journey from today, or even from yesterday, up to, let's say, 2050, when we could dream about autonomous system. And in the meantime, you will see, that's what we saw before with Guillaume and the various timelines, you will see various achievements, various introduction of technology, deployment, certification of AI solutions, but in a controlled manner. We learn by doing. But again, as a safety regulator, we are bound to ensure that the safety level is kept or even developed. Sorry to repeat this, we have a lot of talks with stakeholders, and there are a lot of fears in the public that we could jeopardize the safety through rushing or racing through implementing AI solutions. And our common duty, and I use this word on purpose, our common duty is to reassure the public that what we do is done in a controlled manner to deliver a safe and sustainable solution. And if it is not safe or sustainable, we will have to revise the timelines. Sorry for them. But just one word before concluding. There might not be one solution for all. We are very good, it's a criticism I hear very regularly here, one size fits all. The agency, EASA, is very good at developing one frame applicable to everybody. Here, it might be a bit of an issue. Commercial air transport, ATM, for sure, very cautious approach. We cannot afford any issue with the stakeholders and, most important, the public. So what you could say for commercial air transport 2050 is the best reasonable guess we could do today. And I put a lot of quote around it. It may be less, I'm not sure, more, maybe, we will see. It will depend on how we all together develop the business. ATM a bit similar. ATM will have also probably a very cautious approach. We will improve in terms of efficiency, in terms of traffic management, of flow management, offering maybe some trajectory which are more environmental friendly and so forth, better planning, better calculation. But again, before moving to a full autonomous system, application, whatever it is, there might need a few more years. Well, I have the drone program manager in the room here from EASA. If I tell her that we will at 2050 for autonomous solutions, I'm afraid she will start crying. So I would guess that in the drone community, urban mobility, you may need some special solutions, let's say, not to say treatment, because sorry for my French English, but some special activities to introduce, probably earlier, some level of, again, autonomy or increased automation we will see. So you see, we are very open. We are really looking to your feedback, forward to your feedback. If you are telling us that we should not move toward full autonomous system in the panel this afternoon, we will draw the consequences, but I think you will have some different views. So we will keep working with you, and we will, most important, try to accommodate with each stakeholder needs to better address all of the expectations. So with this, I think I will stop here, Guillaume. Sorry to guide you through all of those timelines just before the break and the lunch, but two main takeaways, or three. This is lessons learned, and the only affected elements are the long-term objectives. Everything else is building on what we have developed all together, thanks to the program team and to all stakeholders who have supported it. Thank you very much, and now I think you have the question answers. Good.
Thank you, Alain.
Thank you. Okay.
So yes, we enter in the Q&A session. We have gathered, I don't know how many, but a number of questions.
Yes.
There is a nice feature in Slido. You can vote for the questions you like the most. So they are popping up slowly. So we'll start in the list and see how much we can manage. I hope most of them. Yeah.
Yes.
Ines, I'll let you
Okay,
read.
so we have a big set of questions. We are not sure if we're going to reply to all of them in time. For sure, we will take note of all of them. And this voting part, it's interesting because you can really highlight what you want to have as a reply on a short basis. So let's see what we have here. So the first question goes like this. What is the level of coordination with the FAA AI Roadmap? Tricky question, eh? Is this of high importance to the industry? For sure it is. So what is our position if we coordinate with the FAA or not?
Okay, I think one of the answers is in the second part of the question. It's important for everyone to have a pure alignment at the end of the day between the different views so that we don't go for double certification standards on the different sides of the Atlantic or even with other authorities. So definitely we strive to work together with our FAA colleagues as we do for any other topic. On this topic, one of the difficulties that FAA is currently working on their roadmap, so they will publish one for the end of the year. I don't know exactly the time it will come, but by the end of the year we should have a roadmap we can work with, let's say, and work together to see how we land together at the same point. And this will, of course, require effort, which have already started, because, of course, we are in contact with the chief scientist on FAA side and FAA management to deal with harmonization as soon as possible, and, of course, dependent on the next steps of getting a roadmap on FAA side.
Okay, thank you, Guillaume. So we have also a hot question, which goes like this. So China invests heavily in machine learning and deep learning AI research, more than all other countries taken together. So are we doomed to be obsolete in Europe if we limit development of AI by legislation and regulation?
It's a tough one, for sure, but here I would say research is great because we need it, and whether it's done in China, in the US, or here in Europe, we will benefit from it. So it's really important. Now, I would not say that we are, let's say, doomed or really not working on that. We have a powerful research, not only in aviation domain, but in all domains in Europe, and we can benefit of it a lot. You will see, of course, through the MLEAP project, but we have the CESAR Clean Aviation, etc. framework, which brings us anyway a lot on that side. Now, are we doomed to be second or third or 10th on AI technology? Maybe, because obviously there are at least 2 big blocks, and probably that will not change tomorrow. But my personal feeling is what we do with AI trustworthiness is not necessarily as developed on the US side or China side as would be needed sometimes to ensure proper working of even more consumer digital type of applications. So I think the work we do with this roadmap and all together with the ecosystem we have created in aviation, but also with a lot of bridges to automotive, railway, will bring a lot and will be for sure reused at some point across the Atlantic or on Chinese side and worldwide. I hope we will see.
All right, so the third question goes to DG Connect. I hope Antoine Alexander is still online and hopefully can reply to this one. And it goes like this. So would there be any examples of already existing AI systems in aviation that will be classified in red or orange area? For example, an acceptance or high risk. There's a specific example here mentioned. How would a biometric system for counting number of onboard passengers be classified? Antoine?
Yes, thanks for the question. I hope you are hearing me well.
Yes.
Red's definitely not. So these kinds of systems will definitely not, at least under the current proposal of the Commission. There will be no specific AI systems used by the aviation sector that will be considered as prohibited from the internal market, as our prohibitions mainly related to social scoring by public authorities and the use of real-time remote biometric identifications, but also by law enforcement authorities. So this definitely not considered as being part of the red category. Now, there could be biometric identification systems developed by the aviation sectors that could be considered as high risk. But here we really need to also keep in mind the definitions that we put in the legislative framework or legislative proposal of the commissions. We are mostly looking at biometric identification systems and not biometric authentication systems. So there it will really depend on the types of systems developed by the aviation sector.
Okay, thank you. So the next two questions are related to certification. So what are the first level 1 AI applications that are already in the process of certification and approval? And the second one, is it possible to provide us an overview of the aircraft manufacturers' applications on AI submitted for EASA certification in aviation at this time?
Difficult questions. I mean, to both questions, definitely we cannot provide this type of details. I think you can read through the press some things going on, but definitely difficult to answer from an EASA side. We will pass those ones. Sorry.
So yes, things are ongoing, but cannot be totally shared at the moment. Okay, so any practical example of the difference between 2B and 3A levels?
What was the question? Any
practical examples?
Yes, a practical example. Very good question.
Yes.
I passed quickly through that. I think we see on 2A side, I would say automation like preparation, for instance, of the cockpit for final approach in terms of flap settings, etc. This could be something that is automatized to a certain extent, with possibly based on some AI-based systems, which will bring us to, let's say, a direct thinking in terms of automatic decision or action implementation, yet not being extremely advanced in terms of nature of the operation, nature of the interaction with the human. That's where we see a huge gap between 2A and 2B. 2B brings us more to, I would say, virtual copilot, virtual co-controller, at least at the high end of the range. And that's something where we see a lot more situational awareness sharing, bidirectional communication, so capabilities in terms of interface and interaction that are ways beyond even what we do today. So with those two, we kind of set the scene. It doesn't mean there is nothing in between. That's really preliminary thinking. For now, that's the type, I would say, of applications I would mention. In the concept paper, you can see a virtual use case, Proxima, which is there to illustrate these 2B capabilities.
Okay, so the following question goes to Nicholas. I hope you're still online and here as well. And it's the following. So, how the decision responsibility could be participated between human and AI regarding the two levels of AI involvement, so assistance and collaboration. It could be participated very differently or more similarly in both levels of AI involvement. Nicholas?
Can you unmute Nicolas, because he cannot do it from his side?
Let's see just if the sound...
Yeah. Just a second, Nicolas, we are back to you.
And here, so... Okay.
Yes, so thank you for the question. I think, well, Guillaume also has been talking about this just in the previous in his previous answer. So decision responsibility in the two levels, 2A and 2B, are quite different the way I see it. So in 2A, the full decision is on the human, whereas in level 2B, it's more of an interaction. So where the AI is becoming more of a partner, if you will, in making the decision, maybe bringing up problems, bringing up suggested solutions if they hit a roadblock. So it's a much more fluid kind of interaction. And that, of course, will require a very, as I said, this secure and fluid communication channel between the AI system and the human, as well as interpretability at the operational level, as Guillaume was saying. So I hope that is an answer to your question, but if you, I'm willing to go into more details. Thank you.
Thank you, Nicolas.
Thank you.
Just one thing to add up on what Nicolas said very well. We have the discriminator between 2A and 2B in the current guidance in terms of criteria is really about this nature of the authority assigned to the AI-based system, where we consider it still full, absolutely full in a 2A type of application, yet with automatic decision or action implementation possibilities. But on the 2B side, it's a conceptual thinking. We consider that the nature of applications that are brought by industry, like single pilot operation, if we take something really as a target, it doesn't have to be the target. Let's see what deploys. But therefore, SPO, if we don't release a bit of the authority to the machine, we may not be able actually to enter in this type of operation. So it's important to see we open, I would say, more possibilities, anticipation of what is needed and what it takes to get there, but it doesn't have to be, we are not pushing from EASA side to say you have to develop this application this and this way. So we are anticipating, I would say. And one last thing I didn't mention, maybe from the core team, EASA, and don't hesitate if you want to complement
Sure.
an answer, you have the mics also. Mathilde, yes.
So Mathilde.
Yeah, thank you, Guillaume. Just as additional information, so for sure we have different concepts between authority and responsibility, and on the figure that is presented in the concept paper and that was also presented by Nicolas. So the authority is more on the operational side, meaning who has the last caller tasks that is defined, and with the same kind of approach that we have today in the cockpit with a co-pilot and a pilot sharing tasks, and your responsibility is on the pilot side. So responsibility, the same in the concept paper. It's more on the side of the hierarchy. For example, we can envisage to have a first officer who has the authority on a given task, and then the decision can be override by the captain if needed, implying that the responsibility is still in the end at the level of the captain. So that's that's the kind of approach we had when we foresee like the implementation of virtual copilot in single pilot operation, for example.
Thank you, Mathilde.
So we have another interesting one. So given the recent concerns voiced about being able to control AI, what is EASA's approach to ensure control remains with humans?
That's an interesting one. I think the first thing we do is you have the building blocks in mind now is first to ensure the intended function of the machine. So even if it's out of control, we will certify for a given purpose, given intended function. That's already kind of a protection. Then we have the human block, human factors for AI, which is exactly about this control oversight. So definitely we have to work and refine and fine-tune this notion of relaxation of a partial part of the authority, because that's a very strong assumption, let's say, to start with. But yet we have this strong, let's say, article also in the EU AI Act to say that any such operations at high risk, for high risk, needs to be under the oversight of the human. So we will keep that oversight. This is really in the concept today, and that's a very, very strong answer, I would say, to the point here. That's the human factors for AI. Last barrier of defense is the safety risk mitigation. As I mentioned briefly in my presentation, you still have also to cope with the unknown unknowns, the, let's say, more uncertainty aspects brought by technology. This is underdeveloped today in the guidance. We have to reinforce that part. So all three things, let's say all three layers, kind of bring a lot of control over applications, and we will not release applications we don't control in any way. Yeah, please, Alain. Alain, if you want to complement. Yeah.
Just one important point here to echo what has been said. There are a lot of talks around us about what we do, how we do in terms of future safety assumptions. And again, you have to bear in mind our assumption, our ground rule here today is we maintain and improve today's safety level. If we can't, we will not go for implementation. And this is a message we keep repeating, but it is not just to communicate, it is because it is our mandate. We cannot do anything different. So all what was said before is very important. When we speak about autonomy, real autonomy with decision, today, in today's legislative environment, we simply cannot do it today. So we have to look forward back to the timeline 2050 and plus, but even before, to introduce this kind of relaxation, what we discuss in the various steering committees and coordination groups is we have to go through a cautious approach here. That means if we can confirm, let's use the buzzword, the CONOPS of a system or a product. Now, if these CONOPS can show us that indeed the safety objectives and the safety case behind is robust and at least equal to what we have today, then we will proceed. If not, we won't, until we have found with the industry at stake, until we have found the right solution to mitigate the risk to our satisfaction. It is back to the public perception. We cannot afford as well. So this is extremely important when talking about future development of autonomous system. Thanks.
Thank you, Alain.
Thank you. The following one has to do with the DOA. So what will AI Roadmap bring in terms of DOA concept?
Okay, yeah, that's an important one. You may have seen in the concept paper, the current version, we have a chapter C6 that is about organizations' requirements. That applies to any type of organizations. And we have an illustration for DOA specifically, what we anticipate being kind of touched upon in adaptation of the framework. We will tackle that. I would say it's a bit underdeveloped as well in the concept paper. That's probably the section that is a bit a pile-up of requirements we anticipate so far, but we need to put a bit of, let's say, structure in that part. So, of course, we will have to deal with novelty in terms of risk mitigation, in terms of training. We have also topics going over auditability. That's what I was looking for, the word, auditability of AI-based systems, which may be a bit actually asking for more insight, more opening even the box than probably auditing is going on today. So all of that is the anticipation we have. It's not yet concrete, but it will turn concretely when we enter the rulemaking concept and the rulemaking plan in the phase 2. And again, that will be presented by Michael, also Gerhard, a bit later today.
All right. The following question is also to EASA. So, you highlight that the level 3C is still a dream, but you consider the level 3B as a realistic target in your roadmap. So, however, how can level 3B be operationally feasible without some level 3C, like intelligence to deal with loss of communication or human incapacitation?
That's a crucial question. I will first answer by saying, again, it's a concept. We have not entered in level 3, so everything I will say is probably just anticipation. For now, what we say is we see 3B, as I reflected it on the slide. It's not exactly reflected like that in the deliverables for now. We have a low-hanging fruit, which would be an increase of the safety case directly. I'm taking one example of the colleagues from the European Defense Agency, the Safe Term project that was done, I think, and ended last year. They have thought about this safe termination of drones operation when you lose the data link. And that's something I would call it a low-hanging fruit, not underestimating the complexity of the use case, but based on perception camera-based systems, you can identify a landing site that would be safer for everyone on ground and properties, but of course people on the ground, than if we didn't have this system. So this is where we see the 3B as a potential, I would say, level we can reach, of course, under the right assumptions, but considering also the safety benefit of the system. If it's an emergency system, we have already a couple of things already even certified that are about really emergency cases, emergency situations. This is why we have put it here in the presentation, saying we don't want to say we will not do level 3 until 2050, because that would be a wrong message. That's why we put 2B as a, 3B as a low-hanging fruit, possible usage of very automated solutions. And to answer completely the question, to me, advanced automation can already bring a lot. You can land with an aircraft completely automatically today. Yet, does it mean it is indeed taking into account all the mitigations that the human pilot is bringing in the operation? Actually, not at all. But if it can save the day, why not? If it's about really releasing totally automatic and autonomous flying aircraft, that's a totally different level of complexity, and that will require this notion of real intelligence and capacity of adaptation, which AI, at least the way we have it at hand today, is not bringing. So this is the reason for opening this thinking of 3A, 3B, 3C, and a lot more to come when we enter the development of the guidance.
Thank you, Guillaume. Anything
Alain,
to add,
please?
Alain?
Yeah, just maybe one point, because there was a very important word you mentioned, Guillaume, emergency. And today, indeed, we have, you can Google it if you are not familiar with it, we have a couple of systems which are called emergency autoland in general aviation. And they are doing exactly what you described today, and it is a fully automated system. It is not autonomous at all, but at least it is saving the day. So what we are working on at the moment is really this increased automation in a developed, more global environment, and those emergency autoland systems are really, for us, a significant safety improvement compared to today's situation when we are not equipped with it. The system will save you from a catastrophic situation. Small airplane, GA, single pilot, the typical scenario with the family on board, anything, incapacitation. If you are not able to fly, normally the flight will not terminate very nicely. So this emergency autoland has now been certified by the FAA and by us on a couple of airplanes, quite high performance. And the automation behind is really brilliant. It's not making decisions in your meaning, if I may say, in the AI program, but it is making predetermined decisions to bring you somewhere where you can ensure a safe, fully automated landing. And when we did the certification, the flight test was quite impressive. The aircraft is doing it all by itself. The configuration, everything is done. And it is not level 2 or 3 at all. It is just automation put at the right place. in a given environment. And that's really opening a fascinating perspective. Thanks.
Thank you, Adam.
Okay, so last questions. Are you projecting a use case tender for cooperation collaboration? A tender? Yes.
Oh, yeah, for sure. Yeah, that's the next topic on the plate for sure. We were focusing a lot on AI assurance, learning assurance so far in terms of tenders. We will look a lot more into human AI teaming in the coming years. We don't have yet, to be very transparent, yet a tender in the pipeline, but it's definitely the next topic. Yes.
Okay, the following one has to do again with alignment with other bodies. So, how is EASA ensuring alignment of AI regulations with government bodies from other jurisdiction? My English is terrible. Such as APAC, USA, FAA, etc. Are we also using use cases and lessons learned from adjacent industries such as the automotive one?
Yes. So the question is really important as well. It touches upon all the stakeholders and the partnership we try to have. I would, let's say, I will not reply again on specifically on the aviation authorities. Definitely we are liaising with them on this topic, and we will ensure as much as practicable convergence in all respects. For automotive, railway, etc., we have a number of partnerships also where we look at what they are trying to solve on their side, which looks very similar to the type of challenges we have. And just to finish on that, we have also the standardization effort that started early, I would say, and that's good because it aggregates also all the partners, including many authorities. And we have FAA, we have Transport Canada, we have ANAC, together working in the WG114 from EuroCAE, SAE G34. And that's a forum where harmonization is going not only in the standard, but also in the discussions we have at higher level on the concepts, and a lot of feedback is coming back to the concept papers, and to be very clear. So it's the key message, in fact. It's an ecosystem we have built. We have all the partners that are very well represented here in the room, all contribute to make the concepts, the guidance itself, the future requirements more practicable, more scalable, and more usable, and very, very safe. That's what we are targeting all together.
Okay, so we have lots of questions in the pipeline. We will take good care of them. I will just finish the session today with one last question. So, which are the role of the university in the maturation of the roadmap?
Yes, another important stakeholder. So academia, we try actually to reinforce this link to academia. We did, when was it, 2 months ago, a PhD scheme, we call it, so the academia meets EASA, to have a number of students, PhD students, bringing and showing their works, not only in AI, in many other domains like sustainable aviation. And this is something we are reinforcing more and more, the link to universities directly, but also directly the link to specific works of students that can flow and let's say augment the capacity to develop guidance. So definitely it's an important stakeholder stream that we are developing.
Very well, thank you. So for the other questions,
Alain wanted to
Alain?
complement.
Yeah, just to echo this, for us, collaborating with academia is becoming really a priority. We have what, it was mentioned, the scientific committee, so since 2 years. This scientific committee is composed of people coming from the academic environment, and we really appreciate the cooperation with them. It has enriched a lot our way of working, collaborating with usual stakeholders, including research institute, but we were missing this pillar, let's say, this academic pillar in terms of independent thinking outside of usual program industry stakeholder pressure. And also something very important, with the academia, we want to prepare the next generation of professionals. Extremely important to us. We have to make sure that together in 6-7 years from today we will be credible technically. And this PhD conference we organized 2 months ago was really for us an eye-opener. We had 3 themes. Out of the 3 teams, one was AI, and you were, Guillaume, the big winner because we had 2/3 of the themes which were focused on AI. So it shows the importance for all of the academic environment and for the PhD students, the importance of this. And what we found, and I think it will be very important to integrate into our program, is that their PhD themes were not flying 50, 60, 100,000 feet. No, they were really tackling issues we have on our plate today. And we have found it's impressive from those young future high-level professionals. We found very interesting potential common questions, common themes, and common synergies at the end of the day. And we will follow some of them, and we are pretty sure that we will come back to you in the future on how to work more closely with academias. For us, it was a big lesson, and we are working and building on it. Thanks.
Thank you, Alain. So yeah, that's it for now. For the rest of the questions, you will have feedback on the EASA website soon after the conference. So break for lunch, and we will gather together again at 1:15. Thank you.
Tract. Luke.
Thank you very much. It's always an honor to speak on these hallowed grounds of the institution that protects the public from unsafety. So I am honored and trying to find out which button to push. No, not this one. Next one. That's me. Luc van Dijk, CEO of Dedalian. Yes. Ha! So what I would like to talk to you about for the next 15 minutes is how we see this roadmap to autonomy in the far future that we just heard is going to be 2050. Which we really hope to be faster than. We are Dedalian. You can pronounce that name however you want. We are about 100 people. We bridge the culture gap between academic robotics, computer vision, deep learning, and the world of safety critical applications in avionics. That was the founding goal for the company. We're about 100 people in Zurich, about 20 in Riga in Latvia, and about 5 in the United States in Phoenix, Arizona. We set out back in 2016 to create a system that could fly like a human, between humans, in an airspace created for and by humans with rules that assume that the humans are very deep in the control loop. And we were inspired at the time by the emergence of many eVTOL and urban air mobility initiatives. And we thought self-driving cars are cool, but self-flying cars, I'm sure there would be value in that. So what we did was we took the CPLH skill test, a booklet from the FAA as our product roadmap, and we went over, okay, what is it that the human pilot actually does? Can we build systems that do all these things and demonstrably better on every possible measurable dimension? That was the goal we set out, and to this day, that's pretty much the definition of our roadmap. When you start, we deliberately started in VMC and VFR because as a human you typically learn to fly there. There's a lot of applications. You can do a lot of interesting things without solving the problem of talking to ATC. And it requires, you quickly find out if you go over the requirements, that you have eyes. You know, human pilots can do without most of the instruments in VMC, provided they can look out the window and see where they are, see where they can fly, and see where they can land. So we have a system working today at a high degree of maturity and close to market entry that can position itself without using GPS. And you can fuse it with GPS, but it's reliable enough to tell you that your GPS is probably being jammed or off because you can still see the same mountain. There's a system that can tell you how you can get safely to a runway or a helipad using no external infrastructure except the same waves as electromagnetic waves as the human eye and visual cortex take in and process. And finally, a system that can tell you where you can fly, because as all of you know, the rules of the air stipulate that if you fly in VMC, doesn't matter if you fly IFR or VFR, each pilot shall remain vigilant, look out the window to give the proper right of way. And it's not a very safe feeling to know that most pilots will tell you that they see about 12 to 15% of the actual traffic that's out there. So we have a system working that uses a high resolution camera It's comparable in resolution to the human eye. It's comparable in dynamic range to the human eye with a fixed iris. Human eye is really very good, but you have to point it in a direction, and we don't have to do that. So we have a system that can scan all the megapixels that we use for this and can detect traffic about 3 miles out. If we had more computing capacity and more pixels, we can up this, but for the meeting the DO387 MOPS, we think we're pretty close. So these three systems, these three functions that are incorporated in the system, they all use the same principle. They take a camera with a high resolution image. They, using entirely classical algorithms, extract the best possible picture from it. Then they run through a convolutional neural network, which draws a box around the runway or around the aircraft or something similar. And then the time dimension is added in classical processing with radar-like algorithms that incorporate the continuity of objects and the persistence of time. So this required certifying the whole thing. So indeed, we showed up here the first time, must have been 2017 or 2018, with the question to do a technical advisory contract in which we were going to ask the experts what would happen if we would show up with a neural network. Because first of all, it's a means, right? It's not, the goal is not to put AI somewhere. The goal is to solve this problem of where can I fly, where can I land, where am I? And for that, there are, for some of these problems, the only feasible techniques require what we these days call convolutional neural networks, and that they are machine learned, and that required figuring out a way to prove that they do what they're supposed to do and don't do things that they're not supposed to do that are dangerous. In other words, known as 1309. So it's relatively well known in this audience that we did these CODAN projects, Concepts of Design Assurance for Neural Networks. We are, in fact, in the middle of an STC through our partner Avidyne in the United States. They are the applicant for a project to an STC under FAA rules, which is being concurrently validated by EASA, which I have announced in many places. So Guillaume, next time people ask, you are allowed to say that. Yeah, we're doing an STC. That's specifically on the traffic detection. It's specifically on pilot assistance. There's a clear safety benefit, namely this thing can see things that other people can't see. It's a clear complement to ADS-B. If eyes were not sufficient, people would be flying with their eyes closed in VMC and VFR using only ADS-B. They're not. Why is that? Because it's not enough. So that brings us to the question, how close are we to this end goal of making a system that can fly like pilot? And are we close to this autonomy where we can take the pilot out? Now, barring redefinitions of the term autonomy, which I don't necessarily agree with, we can take an objective look at what it is that the human pilot actually does. So what are we trying to replace with a machine? And if you think about that, so you often might be tempted to think about moving the stick or pushing the buttons, which are things you can automate. So why is that not good enough? There are a lot of startups that are trying to do this, and then when they ask for permission for their experiments, there's a safety pilot on board. Why is that? That's because the role of the human is not to push the buttons or move the stick. The role of the pilot is to maintain a safe state. This was formulated very nicely by Professor Levison, Nancy Levison of MIT, who defined the safety process as a continuous dynamic process in which you maintain a safe state. So what does that mean? Oh, I had an effect. Maintain. See, look, I'll show you on the computer. Maintain a safe state. So what does that mean? It means that you can't eliminate all the unsafety upfront by static analysis and design assurance and certification, because there's a dynamic component to it. So that's what the human on board is doing. He or she is dealing with all the uncertainty in the environment and making risk assessments. So if we keep building systems that are in the flight control layer, we'll never have a system that actually maintains a safe state. We need to move a level up in the hierarchy of control loops. There's a bigger diagram that this is part of. I've given this talk in this room once before. So we need a system that can maintain the same safe state, and And what does that require? That requires awareness of the environment, awareness of the situation. Situational awareness is a term. We've coined the term situational intelligence because we have a qualified marketing department. But what it really is so what we have today is we have a system that can take information from cameras, and it can take in GPS or altimeters, what have you. It can take in ADS-B and FLARM, and it can fuse all this information using these green boxes which contain machine learned components. And this is actually the place where we think you have no choice but to use some form of machine learning. It's on our website. You don't have to take a picture. I'll send it out later. So with this combined information, in a traditional system, you would then present it to the pilot, who gets to see, this is on my camera, this is on my GPS, what am I going to do now? If you want to make a system that can deal with this kind of information and provide useful output, you have to take in all this data and apply some form of machine learning to extract semantics. So a cloud of points means nothing, but if it's the shape of a mast, then maybe this slight discoloration that I see trailing off in the distance is a wire. For that you need understanding. To understand that this is the Riga and this is the Pilatus and therefore I'm here, it requires an understanding of the pixels that I'm looking at with my camera. To see that this pattern of lines is a runway, it requires an understanding of what runways look like and recognizing them in the world. And finally, to recognize that this 10 by 10 blob of pixels is suspiciously beginning to look like an aircraft, is something that you have no choice but solving with deep convolutional networks at the moment. If that changes, we're the first one to ditch the whole thing, because man, it's a bitch to certify these things. So we think that the green bits, extracting meaning from the data, requires machine learning. To do that safely means certifying them. To do that means coming up with theories of how to assert that they are fit for purpose and not unsafe. So once you have that semantic awareness, you can make a map in which you have, these things are part of the earth and not moving. These things are in the sky and moving. And so you have a handful of categories. You have clouds, which are like mountains, but not quite. So if you have that level of understanding, you can predict the next 10 seconds, you can predict the next 100 seconds, you can predict the next 1,000 seconds, and you can provide guidance away from the danger and towards safety. And we think that the red boxes don't actually require any machine learning at all at this point that we see that we need. So what we first want to do is we want to provide this notionally a dull C to the crew as a good co-pilot, so not as a cacophony of extra signals, but as useful information that tells the crew, hey, maybe you should watch out for that thing over there. And then in a later phase, we're going to fill, so this is the whole diagram. This is what the previous slide was what we have working today. This is what we're working on. So we will add safety landing guidance, seeing if the place where you want to land is clear, and a number of other missing things. We will also broadcast our dynamic mission risk map to other people that are flying around, for which we don't actually need anyone's permission, but we immediately have a system that makes it safer for multiple aircraft to fly around in the same space. Because if I can see you and you can see me, we can maintain an equivalent level of safety at a smaller distance. We can triangulate other aircraft from a great distance, and you can tell me that my plan for landing is currently occupied by a fire truck. Things like that. So you get more situational awareness by sharing this. It's not entirely trivial. It's not entirely straightforward to do this, but the good thing is it doesn't require any centralized infrastructure. So notionally, I think it's the philosophy of flying in VFR, where the responsibilities on board to not fly into things remains intact. And then we want to move this to higher design assurance levels, where the human is moved to an oversight role, and the system interacts directly with the aircraft. And the way we see that is that we could start, so back up a bit. Yesterday at the reception, Dr. Rasmussen, if I remember his name, started with this AI stuff is all very cool, but we can't just allow everything because we have to see if it's safe. And that was a theme that was repeated this morning a couple of times. I think that's the wrong place to start. I think if you have to say, oh, this would be really cool, but is it safe? Why are you even doing it? So I think the starting point should be, can we make things safer? Can we make things safer by having the computers fly? And then you immediately have a different discussion where you're not fighting an uphill battle because you maybe want to do something because it's cheaper or because it's faster or whatever, but is it safe? No, we're doing this to make things safer, and by making things safer, we make new things possible. So we could start by giving all these poor single pilots that are flying Part 23 and Part 27 aircraft, doing dangerous single pilot operations, co-pilot that gets us to the state where we can create aircraft that if you take your hands off, nobody dies, which is not the case today in virtually all aircraft. There's no helicopter that is allowed to land by itself, and in most helicopters, if you take your hands off the stick, eventually everybody will meet a fiery end. So these things are within reach, and we can do them by applying these machine learning techniques, and all we have to do is prove that they're safe, and then we can do all these things. So that's immediately a completely different approach to this whole market, which is why I hope we don't have to wait until 2050. And one way of looking at this is, so instead of creating an uphill battle, we want to do this, but is it safe? At every step, we add safety. We start with, a pilot in a helicopter gets a 4-axis control autopilot that knows how to fly from A to B and how to land if things go wrong. And we expand this envelope, and this way we go around the mountain of obstacles to the autonomous place on the other side, rather than trying to fly through the mountain of obstacles. And how am I doing for time? 2 minutes? Still? Well, I'm actually done. So so this is how we see it. We think that it should not even be a discussion. We should clearly add safety every step of the way, including the very last step where we yank the human out of the pilot and put him or her on the ground to oversee maybe a swarm of these things. We should do that based on evidence that we have gathered in the years before that it is actually safer if that person is not on board. So that's how we execute this roadmap, and I could talk about it for another hour, but I think my time is up.
Thank you. Thanks a lot.
I forgot to plug, for those of you who are here, I forgot to plug, we have a flyer with this material, so come to my...
Thank you very much. So our next speaker is Samir Alam, who is an associate professor at Nanyang Technical University in Singapore. Samir is leading research at NTU to develop the next generation of human AI hybrid ATM systems. Samir.
Thank you for the introduction. Good afternoon, everybody. My name is Samir. I am from Singapore, and today I'm going to give some perspective from the air traffic management perspective. Well, AI human hybrid teaming is very interesting, and the challenge is not about the AI. The challenge is about the challenge is not about the human, but about the AI, whether the AI can cope up with the emotional disturbances of the human air traffic controller or not. So that's a big challenge, I think. Okay, this is working, wonderful. So today I'm going to present some use cases of AI in ATM. I'm from Singapore, and I'll be presenting around 4 use cases actually. One looking for AI for airport airside operation, other for digital towers, then for the terminal airspace, and for en route airspace. So there's some projects that my research team is doing, which I'm going to share with you. So I'm from ATMRI, Air Traffic Management Research Institute. We have around 5 faculty members, 31 research staff, and 18 PhD students. My group focus mainly on AI and machine learning for ATM side. We have air traffic simulation, 360-degree tower simulators, and other facilities to conduct research in this area. So the research aim for my group is to develop a suite of intelligent algorithm that can learn, generalize, as well as predict, not only from air traffic controller actions and air traffic data, in order to assist air traffic controllers to perform higher order cognitive tasks, especially with transparency, explainability, and trust. So these are the driving forces for our research aim. First use case that I'm going to present to you today is about the computer vision and deep learning to detect, track aircraft, drones, and airside vehicles in a large complex airport. This is Houston Airport, as you can see here. So there are 3 case studies that we have done which are being used now at Houston Airport. One is for the pushback prediction, other is for the airport airside surveillance, and the third is for the bird and drone detection. So in the airport airside prediction, as you can see, this is a 6 camera system. The algorithms that we have developed can detect the aircraft, can accurately estimate the speed of the aircraft just by the camera. And also when 2 aircraft are on the same runway or taxiway, same taxiway or taxi lane, it can in real time predict the distance between the 2 aircraft in real time. So we are using this system in shadow mode at Houston Airport. We have developed a specialized CNN algorithm for that, an architecture called as AirNet. It's published in IEEE conference on Multimedia and Expo. The next one is about the turnaround monitoring. As you know, for air traffic controller, it's a very important element to understand when an aircraft that has just arriving can do a turnaround. So this is to predict the turnaround time for an aircraft when it is ready to push back. So the moment an aircraft comes, the algorithm starts working and starts to detect the aircraft and the events that are happening. As you can imagine, there are, I think, 18 different distinct events that are going on in parallel once an aircraft arrives at an airport. So the machine learning algorithms that we have developed, this is trained over 2 years of data at Obihiro Airport in Japan, and can predict the turnaround time for the aircraft. It does it every second and monitors all the activities that are happening at the airside. Then we have a small flying object detection. This algorithm helps to detect drones, birds. As you can see, this is an aircraft which is flying over here. This is a misclassification with very low probability rate. This is a drone over here. So instead of using aircraft shape, size, or whatever, we have used a motion pattern. So we have learned using the motion pattern of an aircraft in the controlled airspace and how drones fly, and use that to develop an algorithm to classify whether an object that's flying is a drone, or it's a bird, or it's an aircraft. Then another algorithm that we have recently developed, this was recently been validated at the Singapore Changi Airport, is about the intelligent departure metering using reinforcement learning. So in this research, we have developed an agent which helps the air traffic controller to decide when they can start pushback a particular aircraft. So you can see over here, there is a big queue before the algorithm was implemented, waiting for the departures. And after it's been implemented, the queue was managed all the time. So this algorithm helps the air traffic controller to advise when to push back a particular aircraft and when to hold it. It learns from the past traffic data, air traffic controllers' interaction with the airside operations, also can do conflict detection, conflict resolution, and can advise smarter flight paths. And this research is about digital towers, right? So in digital tower, you know, we are moving towards one air traffic controller managing multiple airports. So in this research, we have used neurophysiological and cognitive modeling aids to understand how the mental model of the air traffic controller switches when the tasks are changed. So this is airport A, airport B. So this is a set of tasks in experiment. In this one, there are 2 tasks happening at this airport, and then at airport B, a long set of sequence at airport A, and then airport B. So the objective over here is to have the machine learning an ability to advise the air traffic controller to change his focus and attention into a particular airport if such a certain activity is going on. We use eye tracker and other information such as EEG monitoring for this research. Then we also use machine learning algorithms for human embodied gestures for digital tower controller. Using this, air traffic controller can use pinch, gaze, touch, double tap to interact with the aircraft without having a head down time. So AI and machine learning algorithms track using the Kinect sensors and eye trackers inbuilt in the HoloLens, and can see the aircraft, call signs, routes, and all that. This was with one controller, previous one. And this research, the next one, we are using 2 air traffic controllers collaboratively. Over here, the picture is a bit distorted, so there are 2 air traffic controllers sitting here. Both have HoloLenses with them. This is a 3D printed airport, like a Lego. The entire air side has been printed. So air traffic controllers can interact with each other for routing, decision making, path planning, and all that. Okay, in this research, we have said, okay, previously we were saying that an AI helps an air traffic controller to identify which particular airport to focus on. In this one, we have developed a machine learning agent which assists the air traffic controller in managing a airport. So here, an air traffic controller is looking at 2 different airports. This airport is very complex. There is arrival, departure, a heliport mission going on, some pushbacks happening. This airport is relatively very calm, very easy. You can see this interface over here is the DTA, the Digital Tower Assistant Tool. This helps the aircraft which is coming to land here. There is only one landing. To do the conformance monitoring for the arrival aircraft, generating probabilistic bound, and can alert the controller if this aircraft outmaneuvers those probabilistic bound that have been generated. This way, an air traffic controller can focus on the airport where there are significant activities are going on and delegating the other airport to the AI agent. So we conducted experiment with 17 controllers from Hong Kong, from France, from India, and from Singapore. We collected data both for FNIRS as well as eye tracker, and this is a simple toy concept diagram for that. In this research is about TMA, the use case for terminal maneuver airspace. So here we have developed tunnel Gaussian processes to help air traffic controller understand if a flight is unstable or not. So this generates in real time a Gaussian tunnel and understand on various approach landing parameters if an aircraft has an unstable profile. This helps air traffic controller to be warned in advance if a particular aircraft can do a go around. We then further this research using pilots and asking them to fly several maneuvers, 700 maneuvers, different pilots, case studies were performed, data was collected, and a go around a real-time model was generated, which can help air traffic controller also to understand when an aircraft possibly can do a go around procedure. In this research, we are using computer vision and deep learning algorithm to predict the distance to touchdown. So over here in this image, you can see this is the prediction and this is the ground truth. The aircraft is far away. The algorithm actually can predict to 10 nautical miles from finals. And it can tell you what is the distance to touchdown for this aircraft that's coming to land using multi-view vision-based deep learning approach. In real field testing, this is Singapore Changi Airport. The cameras are placed at the instrument landing system ILS location. Not only the aircraft distance to touchdown is predicted, but the relative distance between the 2 aircraft on the final, as you can see, the delta, is also predicted by the machine learning algorithm in real time. This is very useful for the airport that doesn't have an active, ASMGCS system, active surveillance. So in Singapore, we have one airport that's being trialing this system for operations. Oh, this is another one. This is about an AI agent actually helping the air traffic controller to increase the runway capacity. So in Singapore, we have the airport which is running in either in arrival mode or a runway in arrival or in departures. So the agency came us and asked us to develop a system that can advise the controllers to help them to push free departures in the stream of arrivals. So over here in this interface, this is an arrival sequence. As you can see over here, Singapore airport is right here. There are some arriving aircraft over here, and these are the aircraft ready for departure. It takes years of experience for a very experienced controller to understand and have assurance that yes, I can push a free departure in the coming arrival stream in a mixed mode runway operation. Here we have a AI agent that can ask the controller either to hold the flight or to push the departure in the arrival stream by significantly increasing the runway capacity. So when it say go, it also gives you the controller the timer, how much time it can have for the next departure actually. This is another one. This is about how to predict the runway exit for an aircraft. So we have aircraft on finals, for example, here, and also to advise the final approach spacing between the aircraft, which can increase the runway capacity. So the algorithm can predict what is the right spacing between the two aircraft, and can also predict what is the runway exit. This is very important for the airports, which have very complex taxiways, and there are many departures waiting, for slots to go in. It also predicts the runway occupancy time for the aircraft, and can predict the runway excursion if there is a abnormal runway occupancy time here. So it looks into various factors to explain, for example, the influencing factor for this aircraft was the gate location of this aircraft, the category of this aircraft, and other information. So it tries to explain why this particular aircraft is going to take a certain exit. Then we have a classical problem of air traffic conflict resolution. The main challenge in air traffic conflict resolution is that controllers do not want to use such tools. And the primary reason is these tools are mathematical models, well optimized, perfect. Whereas controller wants something which matches with their own strategy. So we set out on this task: can we develop a strategic conformance conflict resolution algorithm where the solution space matches with the mental space of the controller? So we went about to develop a model using human interactive reinforcement learning algorithms, where we first develop a pure reinforcement learning algorithm that tries to learn a simple conflict, and then slowly it starts to become more complex environment with multiple aircraft. So this is self-learning reinforcement learning for conflict resolution with two aircraft vectors. And then we use a human. So here there's a human air traffic controller, and it's trying to stress vector. So we have several hundred controllers around the world participated in this experiment where they try to resolve the conflict. So the machine learning algorithm was able to come up with this mental probabilistic map, which shows which are the go zones and which are the no goes based on this experimental detail. Then we bring the controllers, and then we ask them to do the similar experiments in a high fidelity environment using the escape light simulator environment from Eurocontrol, and try to understand what are the various strategies a controller uses for conflict resolution. Conflict resolution is not just resolving or vectoring an aircraft. It is a set of strategies: which aircraft to maneuver, when to maneuver, how much to maneuver, when to bring it back to its own navigation path. And then this experiment was repeated with several controllers, and different resolutions were demonstrated to them, their own machine generated as an optimized. And we found that the machine generated resolution, which were trained on the controller preferences, they repeatedly picked it up on a higher instances. So that's a summary of mine. This is a new paradigm for data-driven machine learning approach away from the rule-based automation. This enables a human-driven conformal automation and can help air traffic controllers to handle complex traffics, augment air traffic controllers in complex decision-making, and to maintain situation awareness in dynamic environment. That's all from my side. Thank you.
Thank you. Thank you very much, Samir. So our final speaker now for this session on use cases is Juri de Ruiter. Juri is working at Honeywell in its Aerospace Strategic Business Unit and is responsible for the company's engagement in European research projects and programs, including the flagship programs such as CESAR and Clean Sky Aviation. Juri.
My slides on. Yeah. So I will use my human intelligence to operate a machine that I haven't tried before. But I have, based on experience and know-how, that if I push a button that goes forward, that the slide may go forward as well. I've also kind of assumed a certain level of autonomy that I was given by Guillaume after a certain communication and also an agreement on who's taking control at what stage in time. So Guillaume, if I reach the 15 minutes time marker, pull me out. AI is an interesting thing, and particularly in aviation. I think we'll go all together through a very interesting period in time where we will learn more about ourselves than about the machine itself. Because we will learn also why that guy that sits beside us in the cockpit, if he or she wasn't longer there, what actually did we use him for? except for blaming him. And later on, we may not have anyone to blame. Very weird introduction, but it comes to the point where I think from a technology point of view, we will be able to do a lot, my dear friends. Maybe from a legal point of view or other issues, we may be limited. I have to put that disclaimer on here, as one of the projects that will be presented shortly in these slides was a project funded by the Clean Aviation and in the Times Clean Sky joint undertaking. So what drives the research and development roadmap nowadays? Probably a repetition for many of yours, but autonomy is one of them. And you think, oh, wait a minute, autonomy, that's not for today, is it? Well, who drives an automatic, or a car with an automatic gearbox? Any hands? Automatic gearboxes? You have autonomy in your car, because that gearbox decides by itself when it's shifting gears. It doesn't ask you, can I please go to the third gear? It does it automatically. So you allow, and the manufacturer has allowed a certain level of autonomy in your car, in your gearbox, to shift gears. So also that is autonomy. So autonomy is already quite a bit thing into the aviation market as well, and we do more. Digitalization is the other thing. So who of yours has a smartphone? Yep, okay, I understand that. There's a lot of data we as humans already share, and so do we in business. And that is for a very good reason, and one of them is for collaboration. As you all know, air traffic management, or the science of air transport, isn't a science that is driven by just one stakeholder. There's a set of stakeholders that all need to work together already from the design board onwards. That's why, for instance, a CSAR joint undertaking has a very good role to play in the future air traffic management efficiency. So digitalization and the data that we generate of that is a very interesting research area that will be there for a very long time, and which will feed the next one. So if we're into optimizing many things, we want to optimize the costs of our performance as an airliner, as an air traffic management sector, but we also want to be more environmental friendly, because this is what we as humans actually want. We don't want to live in a society that is not sustainable for our next generations. And there's so many more factors that we want to optimize, but things become more and more complex. There's a lot more data available nowadays than we ever had before. So how do we do that? And I think at that time we reach out to a very good friend, AI. So today I'll speak a bit more about AI in a cockpit. So why do we need, or where do we find AI in a cockpit today? Well, yes, we can. Also in today's activities, there are some certain tasks, if I can call it this way, that you can use an AI tool for, to help you, for instance, understand what the air traffic controller so quickly told you. Or maybe to do particularly other tasks where it says, okay, wait a minute here, based on what I'm seeing in front of me here or seeing around me here, just like Luc also presented from Dedalia, there may be a conflict arising and you may want to act. So we can already at that stage use, with today's technology, a certain level of AI performance in the systems. But now we go to more simplified. So simplified, what's that? Well, this is also how programming went. Back in the days I was at school, we learned to program in assembler. Anyone experienced with assembler? It's pretty fun, yeah. But you're really knowing exactly what's going on a bit level. I think nowadays when we ask our children to program in assembler, they say, what? They wouldn't understand what you're talking about, because we bring it to a next level of abstraction. And that's also what happens here. So with simplified cockpits, we bring this all together to a next level of abstraction. Back in the 70s, when the 747 was flying out, there were more than 900 dials and knobs and buttons and switches in the cockpit. And the pilot, or let's say the crew, all had to understand what each of them was doing or what it was informing them about. Nowadays, it's all slimmed down. It's funny sometimes as a GA pilot, when you take a commercial pilot on board and they look at you and say, damn, you've got better tools at your lab than we have in the cockpit. Because in our little world, the GA world, there's a lot more abstraction already possible, and we just use it, right? So That's the more simplified cockpit you could think of, which is today already somehow available, but definitely tomorrow will be the case. And the next level will be, okay, but why don't we use all of that, all the knowledge that we have, all the data that we have, we give it to our good friend AI and say, why don't you fly with me, tap, tap, tap on his shoulder, and you become a hybrid crew. And then this way you could see the evolution of the cockpit and the little elements of AI in there. So you go, if you have this as a project, you go from a task to a work package and even a full project assignment to AI. So there's a little task you give him on the left of the slides, and there's a whole work package you give him on the right of the slides, if you think in program management language. So what are the challenges? We all know, particularly on the left side of the roadmap that Guillaume presented earlier, and Alain as well, on the left side with the machine learning, the deep learning part, there's a whole lot of data that needs to be fed into the system in order to train it. That's not much different than what happens today when you train a pilot. If you look at the flight simulators that we have currently available to train a pilot, they are really, really good and very, very close to what a normal life situation will be around in the cockpit. Why is that? Because over time we collected lots of more insights in how this whole thing flies. We're also able to do a lot more from a technology point of view, so we are able to feed the next generation of pilots with lots more data and situations that they can train themselves upon. The same will be the case for our dear friend AI. If we want to train him, we have to feed him with as much as possible data that comes as close as possible to reality. So the representation or the representativeness of data. I'll take pilot state monitoring as one example there. It's one of the things that this dear friend can do in the cockpit, just monitor the crew. Hey guys, I think you're falling asleep, or I think you're a little bit tense, or maybe you may be overloaded by now, right? So how do we do that? We'll come to that in a second, but that's again a case where if you want to train a system to be able to detect that, you may wonder, how do we do that? One of the other challenges is, okay, then if we have that dear pilot friend on board in a hybrid crew, I think I like the word more hybrid crew than all the others that come around, RCO, SPO, and whatever, it's a kind of hybrid, right? But how do we ensure with a hybrid crew that you fly as safe, if not safer, than we're already flying today? How do we do that? It's very difficult, I think, to kind of put that in one sentence, right? Again there, how do you, from more autonomous operations to a full hybrid crew operation, how do you kind of make sure that you tick the boxes at the end with a signature from the big boss from EASA, say, I believe that this system will do exactly what we're doing today, as safe and even safer than ever before. So on that first part, the data representative, there we go again, representativeness. It's a nice tongue twister. What are the particular challenges in there? There are three that we name here. And I'll start from the left side. Left side is a funny one. I think if I ask many of yours to look at a picture of an Asian person and ask what you think the age of that person is, high probability many of us will be wrong. At least I'm wrong many a times, because I'm not so familiar with these type of faces. That's the same for an AI system. So if you put a different gender, a different background, ethnicity in front of the camera, also that system will be required to judge exactly what you are asked to judge. And then so this is one of the variables that, how do you do that with an automated system, where even we as humans may have a difference in interpretation. Then on the more dynamic part is the middle one, the things that change over time. Your face when you're falling asleep is different. I'm quite sure when your spouse looks at you in the evening, when you sit there in your sofa, I think you're falling asleep. It's probably bedtime, right? So because this person recognizes the changes in your face and kind of detects a certain state change, right? How do we train that AI system to do the same? And particularly also with the last of the three possible changes is while you do that, while flying. I don't know if there is any photographer in the room, but you know very well as a photographer, and the people that make movies know that extremely well, if you take people or you shoot people from a certain in terms of photography, from a certain angle with a certain lighting conditions, all of a sudden they look more muscular than if you light them differently, right? Well, in the cockpit, the light comes from everywhere. Sometimes there is no light, sometimes it's full of light. How do you then at the same time ask the system to exactly judge in what state the pilot, the crew is? So there's so many variables. Think, for instance, of a jet fighter pilot who's pulling some G's. If you first, I don't know if you've ever seen those faces, or at least the change in the facial expressions, you think like, what's going wrong with this person? I mean, this isn't looking healthy, right? Still, we will ask the system, please tell me exactly in what state that person is. So these are the challenges that you would see in data representation if you were to train that. So there's this from the lower side in execution, yeah, and then the top side in the middle of the slides about the training. What sort of a data set do you feed this system with in order to cope with all those three possible changes or challenges? So in one of the projects that we did it this way. We started with this scientific, almost desktop type of literature studies and see what we could find there. From that onwards, we asked lots of people, including our colleagues, who spend time even in the night to go through our labs and be tested and then see, okay, you were allowed to fall asleep now, right? It's your working hours, but you're allowed to fall asleep because we want to detect the stage changes in your face and stuff like that. So we've been in lab training and done quite some tests with a number of people and try and find more data out of that. The data that we then can use to feed and train an AI system. Then we went flying with a number of aircraft, from smaller ones to bigger ones. Fun enough, in our company we have a whole fleet of test aircraft, so there was also a good training for those guys again to kind of, just do something, right? You're free to do something, at least give us as many as possible variables that we could test upon. And now we're in the last stage where actually we go through real in the sense it's just the normal commercial operations and see what more data we could find out there. Is there anything else that we haven't found yet in the 3 layers above that we could feed the system with for testing? So this is on the representativeness. The other challenge, as I said, is the whole teaming, the hybrid crew. And there again, back to the point I made, there we learn a lot more about ourselves than we learn about the system. Because we all of a sudden find out, how did we, or how do we work in a tandem or with more than one pilot in the crew? Single pilot operations is easy for me. I'm a VFR pilot. I fly alone every day. Well, hopefully no, not every day. I can't afford that, but on a regular basis, I just fly alone and do myself. I also know that if I fly with my friends who are commercial pilots, the whole teaming all of a sudden starts to come, because these guys are used to do that. They start to communicate, they start to cross-check, they start to take over tasks that I am not taking care of at a certain moment in time. They start to detect anomalies, and so that teaming starts to work, because these guys are trained to do that. When I fly together with somebody else who's another single pilot, VFR pilot, who's not used to do any crew teaming, is the 15 mark coming? Yes, 1 minute. Then we'll find that some of these elements, in terms of communication, cross-checking, and also starts to fail, because this person wasn't trained on that. And that's the situation where we are now. So we're now about to sign a contract in the CESAR environment, where we will work in learning from what we have already learned on level 1 and bring it to level 2, and then start filling in, and as you see the color changes, the other parts of what crew resource management is all about. The hybrid crew, where this AI friend will be on board, will be just another part of the crew, and we'll have to learn that part to help us in the whole resource management and crew management. Bringing us to the last slide, and what are the challenges then for us ahead of us? Of course, looking at all of it, I will just let you read it. We have half a minute left. But it comes back to those 4, 5, sometimes 6 bullets that you have all around crew resource management. And doing that at a level that you can say, okay, I trust this guy to do it, or I trust this system to take over that role, and I know exactly what it's going to do, and the roles and responsibilities are clear from the beginning onwards.
So thank you, Jori, and to all of our use case speakers, who I think really helped to bring this to life in exactly the way we were hoping for. We're now moving on to our first discussion panel, which is going to look at the question of the challenges ahead as we move towards autonomy. This is going to be led by Jean-Marc Clouseau from EASA, who is responsible for safety intelligence, so safety intelligence this time. Could the panelists please also come forward, and can you bring your name cards, please, so that we can see who you are on the front here. Thank you very much, Jean-Marc.
By the way, the slide is still open, so for your questions, please just highlight the presenter that you are referring to in order to receive your answer. Thank you.
So, good afternoon, everyone. Thank you, Janet, for the introduction, and welcome to the panelists. So we've already discussed autonomy to quite some extent today. We've seen the timeline, 2050, maybe before, maybe later in terms of full autonomy. We've reviewed also the different stages towards autonomy, level 1, 2, 3, with the subcategories. We've seen recently, and I was really, I must say, very impressed with that. We've seen the possible use cases, and I think the perspectives are quite fascinating in many different domains. And in this panel, we are going to dig into the challenges of autonomy from different angles of attack. And I must say something that, normally, when we organize panel discussions at EASA, we provide the panelists with a large, comfortable sofa with a glass of whiskey, so that they can have, very smooth and relaxed informal interactions. But this time, as we thought it's a very serious stuff, we provide them with a stiff chair and no drink. So I hope this will help them to keep focused and alive for the discussion. And we'll have also Ines, you will join us later to moderate the questions from Slido. And Ines, not too sleepy by staying all day on the sofa? No, all good? Okay, good. So who do we have on the sofa this afternoon for this panel discussion? I'm going from the left to the right. Mark Baumgartner is IFATCA Cesar EASA coordinator. We have then Anna von Grote, who is Director General of EUROCAE. Then Romaric Redon from Airbus, who is the head advisor on AI. And then Thomas Krüger from DLR as AI Safety and Security Deputy Director. So we will start with a presentation from Romaric Redon. So Romaric Redon is a head advisor on artificial intelligence technologies for Airbus, this since 2019. He held the previous positions as a data lab manager in Airbus Defence and Space, team leader of Airbus AI research team, and a software engineer in an artificial intelligence startup. And so currently in his role, Romaric is dealing with internal and external stakeholders of Airbus, working on activities related to the safe introduction of AI on critical systems. So Romaric, the floor is yours. Thank you.
Thank you. And we are with short presentation of 4 minutes.
4 to 5 minutes if you
okay. So how do I get it just on the screen, please? Yeah. So I will jump to the first slide just to start to say, to give you a bit about our journey to make AI fly. And it starts with, we are already using AI in aviation, but mostly on ground for not critical application, on link, for example, to what we do on time series analysis linked to our Skywise platform. So the main message is AI is not completely new, but bringing AI in critical system is new, and we will do it in with different steps. So we will have first steps where we are not critical, and I'm just highlighting here two examples where we will be using AI to look, to monitor at what is happening around the aircraft using cameras, quite similar to the use case we've seen for the turnaround time on the airport, but you think you have cameras on your aircraft and you want to monitor what happened around your aircraft, notably to optimize the turnaround time. And we have something that will come, which is called VisioPlane, to do that. And it's not critical, but it will bring a lot of benefit. And for us, it's a way really also to gain more maturity on these not critical use cases. We will also use AI to do inspection, visual inspection of some of the defects. So these are stuff which are on the way. And then we will really go to the next level of putting AI on board for critical application. And in our journey, we are starting with sensor data. We really know very well how to manage and how to make machine learning on sensor data, but we will have to explore computer vision, natural language processing, and I will give you some view of what we have achieved so far in one of our recent demonstrator, and then I will come to the challenge. So we've just achieved the Dragonfly demonstrator. So the Dragonfly demonstrator is something where we are providing and we are using AI for several aspects. So it's something we do on flight test aircraft, so not on aircraft which are sold to our customers. And this is really to understand how far we can go with the technology. So we've been using AI first to provide some diversion assistance capacity. So the idea is to compute a contingency trajectory to a diversion airport. So we continuously compute possible contingency trajectories so that if pilots get incapacitated, we can just safely land the aircraft on a diversion airport. So we compute the contingency trajectory. We execute the contingency trajectory autonomously. We also deal with the ATC speech-to-text and text-to-speech capacity, and by doing so. Then we land the aircraft using vision-based landing, and we land an A350 flight test aircraft. Then on the taxiing phase, we also provide a lot of assistance in terms of understanding where the aircraft should go in terms of taxiing, once again with the ATC providing information about which are the taxiways to be used, as well as guiding the aircraft actually on the taxiway on doing also collision avoidance with the other aircraft or other trucks that can occur on the airport. So that's the kind of stuff we do with AI. For that, we are also collecting a lot of data because we will need, Yori spoke about the data representativeness, so we need to collect a lot of data. Just highlighting the way we show the challenges, and it's quite in line with the EASA guidelines. So we have a first challenge, which is really to define, in order to have the AI assurance and the learning assurance, we have to define the operational design domain, which is not easy, especially in high-dimensional space. We have to get the right data, both in terms of representativeness, completeness, using both real and synthetic data. Then we train our machine learning models, and we have to make sure that our models will generalize well. And all these topics are part of the MLLib project, which we will see tomorrow. Then we need to characterize the performance on the operational design domain, performance in terms of robustness, stability, finding also the level of confidence associated to the prediction. Last but not least, ensuring that when we implement this algorithm on the targeted hardware, we keep all the semantic of the model on all the properties, especially in terms of real-time capacity. Then we see explainability as an overall layer, which is really to improve the trust of the system on the system, both during the development phase and towards end users and auditors. And last, the safety mitigation aspect, because of course a lot of the safety mitigation will be managed not by the human, but potentially by also other systems that will monitor whether our AI system is doing the right things. So these are the main challenges. On just my last slide, on the way we address these challenges is partnership. We already said it this morning, it's key, the aspect of partnerships. So in Airbus, we really try to build partnerships with academics, and we have specific partnerships through Anity, DEAL, and many others, where we try really to come back to new methods for robustness assessment, explainability, and many of the other challenges which I mentioned. Then the question is how you integrate all these methods inside the engineering design cycle, so you can really get that to our engineers. And on the other side, and it will be the link with the presentation from Anna, is really how we really make the link with the standards. So we are very much involved in discussing on building the standards, on finding the link with the means of compliance, so these trustworthy AI methods which are developed, or we can use them in a process to provide elements for means of compliance to some objectives from the standards. And ultimately, the standards, we expect it will be recognized by EASA. So this is all what we do, partnering with academics, with other industrial, and for sure with standards and regulation authorities. And I'm very happy to answer questions on all of this journey that we do together later on.
Thank you very much, Romaric. Our next speaker will be Mark Baumgartner. Mark is working as an operational air traffic controller and a center supervisor in the Geneva Air Control Center for about 25 years. Currently, you are coordinating the CESAR and the EASA activities of IFATCA, and you represent the staff at the government body of CESAR 3. And until recently, you were also the chair of the Eurocontrol Performance Review Commission, and you had been also for 8 years the president and CEO of IFATCA, and that is the International Federation of Air Traffic Controllers Association. Mark, the floor is yours.
Thank you very much. Good afternoon, everybody. I would like to start my presentation with going back. So this is a picture which represents part of our past, of the profession. We are celebrating since 2022. In 2022, we started 1 year of celebration of the 100 years of air traffic control. Air traffic control was invented after a mid-air collision between an aircraft who was flying from Croydon to Le Bourget and the other one the other way around. So air traffic control started in 1922. And here you see on the left-hand side so-called shrimp boats. What we still call shrimp boats, where they pushed on a table a imagined position based on a pilot's report on a map. On the right-hand side, it evolved a little bit with a radar already underlying the shrimp boat's movement, and we are still using the radar. What we think as air traffic control representative is that the artificial intelligence, machine learning, has the same potential to change our job, our industry, as radar had when it started to come into place. So it is something which we are really expecting to change significantly our job, but also our environment. As mentioned, I'm working as an air traffic controller in my day job, and we are experiencing about 40 to 50 changes a year in an air traffic control unit. So we are not adamant or adverse towards change, but we want to be part of it. And therefore we have created a group which is working on the guidance material. What we called is a bit a bulky name for the time being. We're still looking for a very nice acronym. The guidance material for the Joint Cognitive Human-Machine System, where we actually would like to make understand, the industry, the regulators, but also our members, that it's only together, the technology and the humans, that we will be able to produce something which is acceptable and it's intelligent and serves the same safety standard as we have currently. And I will not go into the details, but just here you see what we are discussing or describing in part of this publication, which will come out at the end of the year. What is for us very important is these joint cognitive systems that you have in a cockpit, that you have with a pilot, that you have as an air traffic controller. Whenever you start to move these things towards each other, you create new interfaces, you create new challenges, you create new problems. So imagine that you have a single pilot in an aircraft, in a commercial aircraft. You need to train the air traffic controller to do tasks which nowadays the co-pilot does or somebody else. So you are actually changing completely the system amplitude and attitude. So things like this need to be taken into account. And then this is quite a list we have brought up, which is talking about the myth. There's a lot about myths, which we hear when it comes to artificial intelligence. And these myths need to be identified and need to be discussed together, because otherwise we are just looking at the left-hand side and we say, well, the human will be having much more time, well, the human will have solved all the housekeeping issues and things like this, that the new introduction or the new challenges coming with these new possibility artificial intelligence and machine learning are providing will create new things, emerging properties, new surprises, things like this nobody has seen before. How do you keep the human in the loop, at the loop, out of the loop? Don't give us the leftover strategy. So if the system can't handle it, we still have an air traffic controller who has to do that. It's way too expensive to train an air traffic controller to all the possibilities which are then the leftover strategy. So you need to think when you design these things, you need to think already at the surprises and all these things which were coming. Otherwise, it will not bring the benefits from an economical point of view, but also from a safety point of view to the system if you do that. So I will not go for time reasons into the details of this, but here you get a flavor of what are some of the myths we are being told, and therefore also the idea that we develop a joint view. This is the way to go. It has to be something where we do actually work together with control. And I do expect what we heard also just before, that a lot of things can still be automated, but it doesn't necessarily mean the same thing as when it is autonomous. I have a lot of automated systems giving support to my task, my daily task. And there are still plenty of things, and we heard them just before with some of the user cases, where you actually can automate, increase the housekeeping task increasingly being given to a system. But do not forget, you still have people in there. So you have designers, you have programmers, you will have regulators, and they need to talk to each other together with the operators, and they need to actually bring forward what we want. Do we want only to rely on the new technologies, or are we ready to take off or to take up the challenges of creating something together? And I think that's basically the last slide. Thank you very much.
Thank you very much, Mark, for sharing your views with us. As you said, it's only a flavor so far, but we will have the time to develop that further during the Q&A session. We've said already this morning how important it is for EASA to interface with the research institute, with the universities, and with the standardization bodies, and that's the reason why we've our next two speakers here in this panel. The first one is Thomas Krieger. Hello. Thomas is currently responsible for business development and scientific strategy at the DLR Institute for AI Safety and Security. Thomas studied aerospace engineering at the University of Braunschweig, where he received a PhD on adaptive flight control systems using neural networks. So it's really the focus of the discussions here. And your main principal interests, professionally, I mean, are systems engineering for autonomous and AI systems, trustworthy AI for aerospace applications, and strategy development. The floor is yours, Thomas.
Thank you very much. Yeah, so thank you very much for having me here, and good afternoon from my side. So what I would like to show you in a few minutes are some ideas on the development of AI systems and also autonomous systems from automation up to full autonomy. And I would like to give you some steps in the development maybe, and also some challenges. And what I find very positive is that some of the aspects I collected here have already been discussed today. So it seems to me that there is already some common ground in the understanding of the challenges and obstacles we will be facing in the years up to 2050 and more. And what we see here on the left side is an idea how air traffic might look like in the future and what steps there are from automation to autonomy. So we will see increased capabilities for AI-based decision-making by the systems. So in perspective of this conference, this is not really surprising, but there are some aspects going with it. So what we also heard today and what we see is that there will be, for example, increased connectivity between the systems. So there needs to be more exchange of data in order to have safe flight management, safe collision avoidance, and traffic management between the systems in general. We will also have a more dense or increased traffic density. And this will be applicable to different airspaces, and so this is also a development we will see. Potentially, we will have intersections between different traffic modes. So there might be hubs where we have unmanned aircraft systems, where we have urban air mobility, and where might be connections to automated or autonomous road traffic. How do we handle this? And all these highly integrated systems, they offer a larger surface towards cybersecurity threats. And this is also something which we need to address. So what we can see is we have an integrated complex system of systems, a complex system of systems which needs to be managed while it's developed, but also with the question, how do we manage it over the whole life cycle? So how do we guarantee that complex systems like AI do work over the whole life cycle, considering updates and so forth, or even self-learning? And what we also see is that there are increasing synergies with other domains. So the questions we are raising today here for aviation, they are rather similar in the field of automotive or in the field of space, in the field of robotics. So there are lots of synergies to raise, I would say. Sorry. So some of the challenges to address, and I think these are not all challenges, but these are some of the challenges. So what we really need to understand is a process of engineering, of systems engineering for AI components. So we need to integrate them into system architectures, and from the scientific perspective, we are pretty sure that this will be a model-based approach in the future. We need to design algorithms with increased explainability and with some sort of robustness which we can quantify in order to make them certifiable in the future. We need to address the aspect of data quality, data completeness, and also the aspect of synthetic data, because especially in the aviation domain, we see many applications where training data is a problem, really, to get it. And with regard to synthetic data, we also need to think about tool qualification. How am I sure that the tool is delivering the correct data? We need the right platform for the AI systems to run on board. So we need onboard hardware which is also certifiable for specific design assurance levels, B, A, whatsoever. And we also need to think about new architectures for digital twins, because in the future we think that digital twins will have a larger role in all the lifecycle management and also in the certification process of software items. Then we have the aspect of cybersecurity and also the thoughts of how does AI relate to it? So will AI be attacking AI, or will AI defend against attacks of AI? These are also aspects we need to consider. And resilience of the systems is also important. How do I identify failures? How do I identify anomalies? Is it considered in the system architectures? And how does the system react to failures? These are also different aspects we need to address. And also the non-technical aspects we also address today, the ethics-based assessment, which is also addressed in the AI roadmap. These are things which add a new layer of complexity to the engineer and the developer, I would say, because there are completely new interdisciplinary challenges we need to address, and all these go into the aspect of certification. And in the end, in the long run, we really need to put this all together and think about the lifecycle management of AI systems, and prospectively, with regard to a year 2050, well, we will have learning during operation, I guess. And what this means, well, we do not really know so far. But okay, where to start? One aspect could be the combined V and W model, which was also mentioned before by Guillaume. And this might be a starting point to really establish some sort of engineering practice and some sort of common understanding how to address these systems. So it is, I think, a very good aspect to do so, because we have the traditional V model in the center. It is something we all know from the aviation domain. It is something we know that it works for safety critical systems, and we can combine it with aspects which are new because we want to implement AI. And there we definitely have the systems level, how to integrate AI into the systems engineering process, but also on the left side, for example, in the aspect of data management, what I already mentioned, how to handle synthetic data, for example, how to create this data and use it, but also with regard to learning process management, how to come up with algorithms which lead to a better performance and safety. And with these impressions, I would like to finish. Thank you.
Thank you very much, Thomas. We will welcome now Anna von Grotte. Anna von Grotte joined the Eurocare Secretariat in 2011, and since 2022 she is Director General. Anna has over 15 years of experience in European and international aviation policy and standardization. Anna holds a master's degree in European Studies from the Center of European Integration Studies at the University of Bonn, and a Master of Laws in Technology and Intellectual Property Law from the University of Liverpool. Anna, the floor is yours. Thank you.
Thank you. Thank you very much. Good afternoon, everyone. It's great to see so many of you here within the room, and I gather there's several hundreds also online, which is a real great turnout, and I thank EASA really for organizing this conference and this event, and for giving us the opportunity to talk a little bit about maybe a different perspective than what we've heard from the previous speakers, both in the previous panels. We talked a little bit, or Guillaume and Alain talked a little bit about standards in the morning session, but still, standards are not sexy, as my previous boss used to say, but they're really important. They're a really essential piece of the system. Romaric showed it in his presentation. Really, they are quite central. Guillaume mentioned it this morning. Alain did as well. The challenge ahead, the session is called Challenges Ahead in terms of autonomy. The challenge ahead for us all together will really be providing a comprehensive set of requirements, be that on the regulatory side, the standards, the means of compliance, so that we together can move ahead and allow the industry paving the way forward. The roadmap that was presented this morning will, in that way, of course, act as the baseline, but the coordination here between all of us will be quite key. In Eurocare, how do we address that? We try to address all of aviation stakeholder needs by developing high-quality standards that are built upon the state-of-the-art of expertise, fit for purpose, adopted internationally, support operations, development and regulations, and address global aviation challenges. And I think this, especially the last couple of points, are really important here. How do we do that? We condense it all into the Strategic Standardization Plan, which is our technical work program. It is updated annually by our Technical Advisory Committee, so by the governance of EUROCAE. And what is really important is it is by the members for the members. Jean-Marc mentioned it, I'm by training a lawyer, so you don't want me picking up a pen and writing a standard. That's a bad idea, right? No, it's really the members who write the standard, and the standards are only as good as those that are coming to write the standards. We in the Secretariat are just the ones that pour a little bit of oil into the machine and that make it work, but it's really your platform. On artificial intelligence specifically, we have created a couple of years ago, together with our sister organization SAE, a working group that is working group 114 and G34 on the SAE side. The objectives are to develop a comprehensive statement of concerns that is in the meantime ready and out, but really to develop standards and reports for selecting, implementing and certifying AI technology, acting as a key forum to enable the global adoption and implementation of AI technologies, and finally, of course, to move forward to consider and implement towards the certification of AI systems. The scope here is both on the airborne side, aircraft and UAS, as well as on the ground side, ATM, UTM. I mentioned the statement of concerns is out. It's quite an interesting compendium of considerations, and that's something that we really like to do, because none of us are experts in any of the fields. We cover anything from environmental qualifications of airborne components to artificial intelligence and remote and virtual towers. So really, when we need to get our heads wrapped around a topic, we start off with a report, a feasibility study, a statement of concerns, and this is what we did here. The working group really looked at the concerns of the use of AI technologies and recommended, based on that review of concerns, an efficient roadmap to develop standards for this subject. This now leads to the taxonomy, so starting to talk a common language, which we expect to release before the summer, so quite shortly now. And then towards use case considerations, another report, and finally, and I do hope they change the title of this, a process standard for development and certification and approval of aeronautical products implementing AI, which we expect to release at the end of next year. So again, this is relatively short term. The roadmap in the meantime talks about 2035, 2050, which may seem a long way ahead, but really with the work that we do today in the standardization work, and these are just first steps, but we're really laying the foundation to enable the work and the ambitious goals of the roadmap. Just a brief note on the use cases. There's, I think a few have been mentioned over the morning already. Some of the use cases that are being considered within the working group are the safe autonomous flight termination, the SAFE term, time-based separation, automated visual inspection, maneuver planning, and next generation collisions avoidance systems. The standards, and I'll conclude on this, standards have to be seen in the overall AI ecosystem. We have to have early coordination with especially the regulator, of course, so that we ensure the timely availability of the standard and a mutual understanding and common success. And this is really something which we do on a day-to-day basis. And again, the standards are there for you. See the standards as enablers, not as yet another cumbersome thing to pay for and to send experts to, and that will use up resources. The resources you invest now will pay off in the future, and we try our best to avoid duplications and overlaps by having partnerships, for example, also with other SDOs, with SAE here, we do that very efficiently. We try to have a good collaboration also with Sensenelec, which were mentioned in the morning by the colleague from the Commission, so that we do make best uses of the resources. And especially we work together very closely with the authority, in this case obviously with EASA, but also we have a number of other authorities within the working group. The FAA was mentioned. There's a couple of Asian authorities which are in the working group, which in the meantime has over 350 people working actively on the development of the standards, so that we provide a forum really for coordination that goes beyond just the pure development of compliance demonstration methods. So again, the call, reach out to any of us, do it through Guillaume, through Jean-Marc, through whoever, come contact me after the meeting. The standards are really there for you, see them as an enabler, and so that we move together for common success. Thank you.
Thank you very much, Anna. So we are moving now to the question and answers. So we'll have some questions, probably many questions from Slido in a moment. But first, I will start with my own questions, if I have the right. Yes, I have the right to ask a few questions. That's good. So the first question, I think it's rather for Romaric and Mark, but of course the other panelists may answer that. So we've discussed the path towards full autonomy. Guillaume mentioned the dream of full autonomy around the years 250. Is it a dream? Is it a nightmare? The question is, in fact, where will we stop on the path towards full autonomy? And that's a very important question for two, I would say, safety critical functions, the pilot and the air traffic controller. So my question to Romaric and Mark is, do you see that sometime in a close or more remote future, we will have, thanks to the development of AI, no pilot anymore in the cockpit, or no air traffic controller in the control tower?
Okay, so maybe should we use that to, is it activated? Okay, thank you. So the short answer is we see no future without pilots, at least for what we can see and predict for now, for at least large commercial aircraft. And the main reason for that is the AI today is indeed progressing very well, and we reach human level performance, but mostly linked to data-driven approach, which means we need a lot of data to make something which actually is relevant with AI. And in fact, we know there are unknown situations. So there are situations for which we just don't know them. And pilots are, for this kind of situation, the best really to be in charge. So really on our side, we see no future without pilots for large passenger aircraft. Also, I mean, I've shown some of the results we had with Dragonfly, where we are showing we are capable to divert an aircraft without pilot in the loop and to land it autonomously. But the point I want to make is we are doing it to the level it can be performed autonomously, because it's the only way that we can ensure the right level of trust to use it in assistance mode. Because what we want to do ultimately is provide assistance to the pilot. But in order for the pilot to trust the system, they need to be sure that the system is going to do the right things and that they can potentially decide to fully trust it. So the demonstration we do is without pilot in the loop, but that's not our intention. To remove the pilot, because for many good reasons we wish they would stay in the cockpit for a long period of time, I would say, at least as far as we can forecast.
Yeah, thank you very much, Romaric. In a way, it's quite reassuring to see that after the peak of enthusiasm that we had a few years back where we thought that AI would be everywhere and the human will be removed for most of the critical activities. We are now back to a more, I would say, pragmatic approach with, you know, this teaming between the man and the machine. And Mark, what is your view on that?
Well, it's an easy one. Of course, the human will stay. For an air traffic controller, he thinks to stay. But seriously, the job will stay for legal and societal issues. So even if technology at one day would be capable of doing these things, I think we are still far away from a societal acceptance. You need to be able to blame somebody if something goes wrong. It has been mentioned, I think, by the gentleman from Honeywell before. You need in our legal system to have that. But the working environment will completely change. Mind you that in air traffic control, we are, if I may use the comparison to the phone industry, we are at pre-G1 levels with the infrastructure. We are monolithical, vertical. We have prototype designs for each and every system. We are fragmented and things like this. So the new technologies hopefully will not solidify this fragmentation, but will break it up, and will break it up in a distant way, in the sense that you will most probably see data centers being transferred, being digitalized, and being transferred into some sort of cloud server application where you then ideally can download what you need. Because nowadays, an air traffic service provider will maybe develop prototyped systems for things he uses twice a year or 3 times a year, and it costs a lot, and then he has a physical system, whereas in the future, if you can download these services, that makes the whole environment much more dynamic. And I mentioned as well before, I'm still talking a lot to my colleagues, the pilot. Not that I dislike that, but I'm still doing a lot of housekeeping things, changing frequency, tell him to turn left, tell him to turn right. And despite the fact I'm still claiming that I'm working in one of the most advanced centers, so conflict detection and attention guidance, all these things we have already in place and we use it every day. But still, I'm still talking to giving instructions and things like this. So that, I hope, will change, the working environment. And by changing that, the profile of the people you need to select, which is a challenging one, because I'm one of 800, who go into selection process. We have miss rates of 40 to 60%. So people who start training, we only get between 40 and 60% out of the training classes into the ops room and then being qualified. That is something we cannot continue, and I hope that at least this part will be maybe a profession which will be more accessible to people who do not have a specific talent. So I think there we will see the changes.
Yes. Thank you very much, Mark. And I think that vision of AI at the service of the human and not the reverse is something which is also quite reassuring, and I think it is a vision that we can all adhere to. So I have now a second question, and then after that question we'll move to the Slido questions. I would like to ask all the panelists to tell us, in their opinion, what are the top 2 or 3 upcoming challenges and possibly opportunities for the aviation community regarding autonomy. So quickly, 2, 3 opportunities, challenges regarding autonomy. So you want to start, Thomas?
Yes, thank you very much. With regard to the challenges and opportunities, maybe I limit myself to one each. So I mentioned it before, and we also discussed it already. What I find very new and challenging, and where we also started to build up a separate team, is the question of the ethics-related assessment of these systems. So we, as a technology-driven domain, how do we work with these new problems? These are interdisciplinary problems. We have new aspects of legal questions. We have questions of fairness, of non-discrimination. We have questions of acceptance of these systems. And for these challenges, I think we need some new solutions and new teams being combined of of engineers, computer scientists, but also people from the legal domain or political and social sciences and so forth. This is one of the challenges, I guess. And with regard to the opportunities, I think especially connecting with other domains is something where aviation can really profit, but also other domains can profit, because aviation has a track record of delivering safe systems and having the processes which many other domains do not have, but also strive for autonomy, like automotive, for example. But on the other side, there is, in the automotive domain especially, much drive. And there are many big companies also striving for AI functionalities, and learning there from each other. I think this is a big opportunity we have.
Okay, so I will follow with one. If I have to take only one, would be for me the robustness challenge, and especially, I mean, what is key is to know when the system is not working, and it's not an easy question with machine learning. With machine learning, often you have a quite good level of performance, but you need to know when you should not trust the result of your prediction. And so this aspect of really building the right level of built-in robustness on the monitoring capacity that will tell you when you should not trust the system. And ultimately, in aviation, we are quite used to system that does not work, as long as we have a monitor that tells us that the system is not working. So that's really the one I would pick. And in terms of opportunity, I would just, I mean, Guillaume spoke about low-hanging fruit. I would really like to push for AI as a way to improve safety. So there are a lot of use cases. Safe term was mentioned, but also, I mean, we have the ACAS XU, for example, use case in the EuroCAE working group for finding a way to have a next generation of anti-collision system on board. So there are plenty of use cases where AI is enabling to provide new safety capacity in our system. So not thinking always that, really thinking positive that AI can bring us to new level of safety, which is all what we want for.
Thank you, Romaric. Anna?
So in terms of challenges, I guess from our point of view, one of the big challenges is being able to develop the right standards at the right levels at the right time. And for this, we really need early engagement, early planning. The earlier we can get on with an integrated approach, the better. At the same time, though, we have a huge opportunity in this. I think it was Alain who mentioned it this morning, supporting the competitiveness of the European aviation industry and community. I think we have a huge opportunity to use standards to build up competitiveness and to export European knowledge and leadership to the global aviation market. If we take the example for ED240, for example, for remote and digital towers, this is something which has started in Europe, which was very incremental, one iteration of the standard, always adding more and more, and as the research matures. But in the meantime, this is recognized worldwide as the standard. So we can also use standards as a vehicle to bring our knowledge and our leadership to the global aviation front.
Well, for us, I think the challenge is that we do not fall into the trap of the myth I show. So if we don't go open eye into the catastrophe, as I think the French have a saying for that. So I think it really is something which is important. That's the challenge. Is typically an aircraft trajectory, a 4D trajectory, is deterministic. So you can work with that. But air traffic control is not at all deterministic. So how do you cope with this challenge? Things like this. On the opportunities, well, coming back to what I said before, if we could reach a 1G level maturity of the telephony, that would be wonderful. Ways to go there is, for example, to have one single flight plan, only one flight plan per flight, one flight plan. That would be already something so dramatically improving the defragmentation of the system by digitalizing just one piece, the common piece, we work with. There are other things, like we're talking about remote tower, digital tower, but why are we not using all this fabulous technology we have seen, use cases, to improve low visibility procedures? We reduce capacity when there is fog or bad weather by 30 to 40%. Why are we not using this technology instead of trying to control remotely placed airports and things like this, where there is maybe 2 aircraft a day, where you can have big platform airports where you have to reduce 40% the capacity, and suddenly, thanks to technology, you can run nearly 100% operation. So these are things where I personally see a lot of opportunities. Thank you.
Thank you very much, Mark. I think that we can move now to the questions from Slido. So Ines, I let you run the show for that.
Okay. So we have more or less 10 minutes before we do a break. Of course, Slido will be continuously open, but I have a bit of, some questions for you. So Thomas, the first one is for you to reply. So can you explain how you see the quantifiable robustness on a machine learning prediction?
So, to be honest, it's a very difficult question, and with regard to really being able to quantify the result of a neural network, for example, this is, in my perspective, something which is connected, well, with also physical information, for example, which you would use from an aircraft where the AI component is implemented. This could be one aspect with regard to, for example, stability analysis of the algorithms and analyzing the convergence. And also with regard to adding different information which is available by sensor systems within the architecture. So I think combining improved algorithms with in the architecture of the system and adding this information is one aspect which we might follow. But it is a question of research and not completely clear.
Okay, thank you very much.
May I complement?
Of course.
I mean, I think there will be more elements tomorrow coming from the MLLeap presentation, but just there are first different categories of problems. So depending if you are with low dimensional problems, small neural networks, or high dimensional on deep neural networks, the robustness problem is not the same. And actually for small networks, low dimensionality, we have now formal methods which are performing quite well for verification of neural networks. So we can actually prove some properties in terms of robustness for this kind of categories. When you go for high dimensional use case on deep neural network, it's still a topic how much we can potentially scale these formal methods. And I think more of that will be covered tomorrow in the MLLeap presentation.
Thank you. So looking forward for tomorrow. The next question, it's for Mark. So it goes like this. What does the role of an air traffic controller entail when it comes to unmanned aircraft systems, such as large drones, where AI-based functions and services assist remote pilot responsibilities, sharing similarities with traditional air traffic control? How do you see it?
Very pragmatic, in the sense, as an air traffic controller, if a flying object, you can name it as you wish, wants to benefit from air traffic control, it has to stick to the rules. If the rules do not allow certain operations, you change the rules. That's what we're currently doing for the big remote pilot system at ICAO, that we can use some of these new technology to do detect and avoid, and that will come. And then it is another participant with different means, sense and avoid, detect and avoid, which will be part of the system. Everybody will be trained, and actually, I personally do not see it as a huge issue, as long as the new entrant is capable of doing what is expected from a regulatory point of view, I'm executing that. The only problem is, what if, and there it becomes interesting. What if a flyaway route is unknown? So if you have a C2 link failure, suddenly the system is autonomous, and it decides in his own autonomy what to do, and nobody knows what it does. Then it becomes interesting, because I will be still sitting there, and there will be still my colleagues flying the commercial aircraft, where we suddenly have a flying object which we don't know how it behaves. And it's not an aggressive, it's some sort of a passive thing, you know, which will be flying somewhere, and we have no clue. So how do we cope with that? It's less the normal operation. It's really the, if I may call it, degraded operations, which are the most challenging part for us. But other than that, if we find a solution where the RPAS tells me, or the pilot tells me C-Link 2 failure, escape route or automatic remote fly back route is such and such and such, I can do. Nowadays, we have global hawks. When they land in certain military airports, the civilian, they stop the traffic at the civilian close by airport because they don't know how the return to home route has been programmed. So that's the answer currently of the system. In the future, we will have to find other answers.
Okay, the future will tell us. I have some questions also for the previous presenters. So I will ask the help from Luke from Daedalene. I hope he's still on the room. He can use his microphone, or maybe Caranta, maybe. Sorry? Okay, so I will we will take this then for later. Then I hope Samir is still on the room. Yeah? Okay, then I have a question for you. So, considering your presentation, Samir, have you done an analysis how much capacity can be gained by implementing your systems at complex hub airports? You can use your microphone.
It is the machine learning system. There was an increase of around 27% in the capacity for the mixed modal operation. So that was.
See?
Yeah. So there was a 27% increase in the runway capacity for the Singapore Changi Airport when we attempted the machine learning agent to help the controllers for mixed mode arrivals and departures. Also, when it comes to the intelligent departure metering aid, we were able to cut down around 3 minutes of taxi delays per aircraft, specifically waiting at the runway holding points. So these were the two important highlights when we did the analysis with controllers in the loop. Thank you.
Thank you so much. So I have another question here for Hannah this time. Okay, could Hirokai explain the main core different considerations on the airborne and on the ground applications?
I guess that will be very dependent on a case-by-case analysis of each of the different applications. The idea is that the standards we develop are methodology standards, so that they can be applied to any system, and the analysis for each system. The application will be dependent on the system itself, on the intended use, and the intended operations.
Thank you very much, Anna. All right, so we were going to interrupt now for coffee break. I hope everybody is online well, also having a bit of time for a bit of coffee, and we will resume at 3:30. Thank you.
Last people are just coming into the room in Cologne, and then we'll set off. Okay. So we're now moving into our final section of today's agenda. Just a reminder that we'll have a Q&A at the end of this, so please do put your questions into Slido. The information's back up there on the wall in case anybody's missed it at this stage. So hashtag AI Days, and the passcode is AWRT0L. AWRT0L. So we're now going to turn to the question of EASA's rulemaking concept for AI, and who's better to introduce this to us than our Safety Programme Section Manager, Michelle Gerhardt. Thank you, Michelle.
Thank you, Jeanette, and good afternoon. After so many interesting technical presentations today, a brave decision to close this discussion with a rulemaking topic. I saw, I think it was Luc on your slide, some pictures of your studies on people's face expression when falling asleep. So at least in the room I can monitor that. So for 15 minutes, please bear with me. What I have in mind is to present you the rulemaking concept that we have in mind, that we have laid down in the roadmap on how we see it's possible to enable the use of AI, as we said, in a safe and sustainable manner. So that will be the topic. My objective is to show to you how we can transform the good ideas that you see in the roadmap and that you see in the concept papers that were developed in the phase 1 of the project into regulations and AMCs. And I will have basically two focuses here. First focus is about on the rules architecture, where to best place these requirements. And the second one is then on how to transpose the ideas from the concept paper into regulations. I will also link that and close the parentheses that Antoine Alexandre opened this morning on the AI Act. So I'm trying to link these ideas to the draft AI Act that we discussed this morning. So by the end of this presentation, you will hopefully have a better understanding on how we plan to deliver a regulatory framework to enable the use of AI in a safe and sustainable manner. So to link that back to the discussions this morning, this is the picture that you saw presented by Alain. We are now focusing back into phase 2 of the project and see how the thoughts in the concept paper can be developed in a regulatory framework. So in order to do that, let me have a look on how civil aviation safety is regulated today. This is what you see here on the slide. That's the regulatory framework, the architecture as you see it today. From here, I would like to develop the thoughts on how we can regulate, enable artificial intelligence in an effective way and fit for purpose. At the high level, at the highest level, you see the basic regulation, Regulation 1139 from 2018. In this regulation, you'll see all the substantive requirements on civil aviation safety. This is a Commission and Parliament regulation, and in this basic regulation, you'll see, sorry for a bit of formal language, formal stuff. In that basic regulation, you see empowering provisions on the Commission, so the Parliament and Council delegating, empowering the Commission to develop rules for the implementation, for the harmonized implementation of these substantive requirements and detailed requirements for the application of these requirements. This is what in our day-to-day language we're calling implementing rules or implementing acts and delegated acts. Please keep in mind this boring element of empowering regulations, empowering provisions in the basic regulation, because I will come back to that later in the presentation to link this idea back to the AI Act. Under these empowering provisions, since 2002, the Commission has developed these implementing rules, this tree that you can see underneath the basic regulation, which are then providing the requirements necessary to apply these substantial requirements in the basic regulation. You know them as Regulation 748, Part 21 for initial airworthiness, Regulation 965 for ops, Regulation 139 for aerodromes and so on. The historical reason why we have done so, why we have this rules architecture today per domain, is because the member states transferred to the European Union the power to regulate and to deal with civil aviation safety in a gradual manner. Starting in 2002, 2003, the transfer was, or the competence was transferred on airworthiness. In 2008 on OPS and FCL. In 2009 on ATM and aerodromes. In 2018 on drones. So this gradual transfer of competence also led us to develop the implementing rules in a gradual manner. So 2002 to 2004 we developed the implementing rules for airworthiness. 2008 to 2012 for OPS. 2009 to 2014 I think it was for aerodromes. This domain-specific approach may not be necessarily fit for topics which are transversal, which are horizontal. But how can we best deal with such horizontal topics when they are affecting all of the domains? We have already today examples, also in recent rulemaking activities. For example, let me mention safety management systems, where the integration or the transposition of the ICAO SARPs on SMS happened in a gradual manner because they took place while we were developing this domain-specific rules architecture. We started with OPS, and now we are finishing these days with initial and continuing airworthiness. We have also other similar elements in all of these regulations which are horizontal, very often in the so-called authority requirements, in the organization requirements, which are identical or similar in all of these domains. That of course has a clear advantage. You as a user, you know which regulation to turn to. You know, if I want to know the requirements on OPS, I go to regulation 965. But it also has a clear disadvantage, or several disadvantages. One big one is if we develop the requirements which are meant to be common, similar or identical in all of the domain, and we start with one domain, let's say OPS, we consult, we discuss the OPS community, then we enact them in the OPS regulation, and then want to use the same principles with the airworthiness community. Whatever discussion we start with the airworthiness community, consultation, we need to find a balance as EASA how to ensure that the voice of the airworthiness community is heard. How can we take the comments on board so that we ensure that they are reflected, or if we are not doing that, we stick with the identical regulations in all of the domains. So that is a real difficulty, and it becomes even worse if we have to maintain the rules afterwards. We have to do it throughout all the domains. As soon as we start doing that in every domain, bit by bit, we can forget about a consistent approach. So we have changed the approach in the recent years for that reason, that it's much easier to have common rules, common requirements, regulated in a dedicated act. We can do so because we have found tools to mitigate the disadvantage that can bring for you as a user, because you will not find any longer the rules in one dedicated act. By now we have transferred, migrated the rules into data. We have e-rules available. You hopefully know about that, which allows us to compose every rule in every way we want to, and we are developing functionalities to enable that even further. So we are now at a point where we have for the first time regulated a topic not in the domain, in the historical rules architecture, but really a cross-cutting and transversal topic in a dedicated regulation. That were the two regulations on information security. So here we are today. And you may already see where this introduction may lead to. AI is also a horizontal topic. It's a topic that affects several domains. So how can we embed AI in this rules architecture in the future? What do we have in mind? This is, in an abstracted way, the picture that you have seen on the previous slide. We have the basic regulation. We have the domain-specific implementing regulations, and I'm sure you know about, and we've mentioned them before, acceptable means of compliance and guidance material. This is the aviation-specific view. We now have heard this morning about the draft AI Act, which will provide or establish the fundamental requirements for all sectors utilizing AI, not only aviation. Please take this picture with a word of caution. It's not that the AI Act is above the EASA basic regulation. Both are Parliament and Council regulations. Both work hand in hand. They're at the same level. The picture that we want to give here is that the AI Act is addressing all sectors and not only aviation. What the AI Act will supposedly do is change our basic regulation. In Article 81, the current draft, there is a provision, or Article 81 will directly amend the basic regulation, 1139. No further rulemaking activity needed from our side. And what is the content of that change in the basic regulation? And now I'm coming back to this boring part, the empowerment provisions. The empowerment provisions on the Commission will be changed. They will oblige the Commission, whenever working on the domain-specific implementing regulations, initial airworthiness 748, ATM ANS regulations, UIS regulations, to consider Title 3, Chapter 2 of the AI Act, so Articles 9 to 15 of that draft regulation as it stands today. Risk management system, database, data and data governance, technical documentation, record keeping, transparency and information to the users, human oversight, accuracy, robustness, and cybersecurity. A lot of topics that we have discussed today. So hence, what the Commission has to do, and the EASA supporting the Commission in preparing this regulation, is to think about these elements in Article 9 to 15 of the Draft Act, how to reflect that into the initial airworthiness regulations, ATM regulations, drones regulations, when amending these regulations. And that's the idea, that's what we have done, that we have started to do with the AI concept paper. So the idea of rulemaking is now to transpose these ideas from the concept paper into regulations. And we will do that, we plan to do that in 2 steps. The first one is the common requirements, which are relevant for all of the domains, to put them in what we think today could be a Part AI, with trustworthiness requirements, authority requirements, and organization requirements. If you are familiar with the new Part IS, information security, you know that structure. That's the idea, we copy the idea, the concept from there. Also, we know that we need to have some AMCs, and basically that will be where the essential parts of the recommendations from the concept papers will be. The Part AI shall be objective-based, performance-based. We cannot do prescriptive rules here. Step 2 will then be to look into the existing domain-specific regulations, 748, 965, and see whether we also need to change something domain-specific there. So we will assess that and then come up with proposals there. You see this concept already in our European Plan for Aviation Safety. In the 2023 to 2025 edition, we have identified the need, the possibility to regulate AI as one of the strategic priorities of the agency. an element of integrating new technologies in a safe and sustainable manner. You see that in chapter 3.4.1. And today what you don't see in the EPAS, in the current EPAS edition, is a rulemaking plan. How do we plan to address that? This we are currently discussing. This is what you're going to see in the next edition, in the 2024 edition of EPAS Volume 2. So to conclude that picture, we've mentioned that before. Also, the industry standards are an essential element of it. We are part of EuroK Working Group 114 and the SAEG 34 that Anna presented. We're also monitoring the work of ISO and IEC, and also Sense and Elect, as mentioned by Antoine Alexandre this morning. We are following that, and it's important that these three elements of industry standards are well coordinated. So allow me one last word, just to close the topic. What you will find at a high level, objective-based, performance-based in the part AI is actually what you see in Article 9 to 15, Title 3, Chapter 2 of the Draft AI Act. What you see here on the right-hand side are basically the articles that you find currently in the Draft AI Act in that Chapter 2. As developed, as thought through, how they are relevant for aviation in the concept papers. So we will, of course, continue that discussion, that rulemaking discussions with you. It's important that we get your voice, that we get your input on all what we're developing here. We are at the starting point. We know what we have to regulate. We know a bit how we are going to regulate, but we will reach out to you. We will consult you, and how we are going to do that you will see in the working methods that we are going to show in EPAS when we show you the rulemaking plan, the rulemaking program for that rulemaking task.
Thank you.
Thank you very much.
Thank you.
Okay, we are moving into the next Q&A session. So I hope you extensively use the Slido. For that, if I can call the use case presenters to the floor also, in case there are some questions for you, Luc, Samir, and Yuri. We have put your names here on the table. Let's move the camera maybe back to...
Yes.
Yeah, thank you.
Okay. All right, so we have some questions already showing up in Slido, but I would like also to open a bit the floor to all of you that are here in Cologne. So in case you have a question or a comment, please feel free. You have your microphone, so it will be just easy, okay? But I will then start with a question that we already had. It's actually for you, Luc, okay? And it goes a bit like this. It's actually a bit of a provocation. I agree with your approach to look at ways to make the system safer, but I'm wondering what your definition of safety is. Minimization of bad outcomes or maximization of good outcomes? How do you ensure the right data is being looked at?
That's a different question. That's a different question. So I guess what? Just once. These UIs are terrible. Okay, you hold the button. I talk. Okay.
Yeah. Great.
What is the European Aerospace Safety Agency? What is the definitions of safety that you use in your acronym? I would say it's the not having bad things happen, right? We worry about worst case in aviation. That's also what actually makes it an interesting intellectual challenge, because when you write computer programs for fun in internet land or for a living in internet land, you care about best case performance, but in aerospace it takes a different mindset to worry about the worst case. So it's quite clearly eliminating unacceptable bad outcomes. And formulating the requirements is far from trivial. So the actual interesting question is, how do you make sure you look at the right data? And there we have a principle that you can summarize at, it helps if you know what you're doing. So I think any sort of a priori shopping list for, well, this is AI, and therefore you need to look at this data, is doomed to fail, because it depends very much on the thing you're doing. So if we look at trying to detect aircraft in images, you have to look at a lot of aircraft in images, and you have to come up with a valid argument that you span the input space, and for that you have to actually look at the input space and gather actual data, find patterns, and understand the high-dimensional nature. And that in itself is far from trivial, and it's a large part of the engineering. And it's a large part of the secret sauce. Just like if you design a turbine engine, you know, you have to know what you're doing, and you have to bring data that's relevant. And it's hard to capture that in a generic recipe up front. I'm not sure if that answered the question.
All right. So we have another question that it's actually for everybody, so feel free in the panel. It goes a bit like this. So, automotive community to manage the complexity, invest in a common language to specify a safe behavior. A language used to find an agreement on the specification of safe behavior between different actors, like infrastructure manager, safety engineer, regulator officer. How do you see this? On a common language between different actors. Who wants to start?
Okay, I can say something. When we started the first CODAN project, Concepts for Design Assurance of Neural Networks, which we didn't know was going to be the title, but I know we had our very first meeting in a room here in this building, and so we came from a largely academic tradition where words like random have a very specific meaning tied to the Kolmogorov axioms of probability. And it means something completely different in the world of safety-critical aviation. So we had a conversation where at some point people were like, whoa, no, that's not random. And I went, of course it's random. And then, you know, that's not all to it. And then so it took 15 minutes to find out that we were actually using different meanings of the word random. And so to bridge that gap, that was actually one of the first concrete positive outcomes of these IPCs, is that we understood that, you know, this word actually means something different, and we've bumped into numerous examples of that. So having a common language, definitely a good thing. I would say good thing. That it has to be a formal language, that we need a committee for who redefines words that then nobody understands what they mean. Not sure if that's a useful approach.
If I may complement, yes, thanks, Luc. I fully agree that starting point is a common taxonomy, set of definitions, else we cannot agree, or we cannot find an agreement in some ways, because we are just speaking about two different things. So that's a careful thing to do. And just to rebound on the question on automotive, we are borrowing some of the concept from automotive, like the operational design domain is inherited from that field. And we are trying as much as possible to stick to their concepts, look also into their open ODD type of concept that can enable one step further. And last thing, I will also complement with standardization. Creating standards is the way to get everyone in the room to have a common taxonomy, a common language, a common set of even safety, I would say, related objectives and definitions. So we can standardize up to a certain point, probably not everything and not beyond, let's say, understanding, because else we may become prescriptive, and that's what we want also to avoid. So that's a fine line to find, but definitely common language is the key. I agree. Thank you.
Very well. So we have here also a question for Michael. So about the rule-making concept, why part AI is foreseen and not CSAI? Is it because it is considered a transversal discipline?
No, that's not the main reason. Before we think about certification specifications, we have to think about the requirements. If certain elements for which we want to put requirements, enablers, those have to be in the regulations. Then the technical elements of that like today for the certification specification, large aeroplanes, or for an AMC 20, those can then be, at the technical details can then be at that level. Guillaume, you may complement, but in sense of the guidance that was thought about in the concept paper, there are a few elements which we identified which are necessary at the requirement level. Those ones which are linked to, I'm coming back, sorry, to Title 3, Chapter 2, Articles 9 to 15 of the AI Act. Those have to be in regulations, and then the details can be in AMCs or in certification specifications.
Absolutely.
So, second question for you, Michel. Okay, it goes a bit like this. So, EASA Special Conditions, SC AI 01, levied the objectives of the Level 1 concept paper for small aircraft. Does EASA intend to publish SCs for transport aircraft as well? EASA anticipates more direct regulatory rulemaking in the future for AI machine learning or similar concept paper-based SCs.
Yeah, I will take this one. So the special condition is the tool we can use indeed to provide a set of requirements on top of existing ones in certification projects, in initial airworthiness. And this is something we used indeed because we had some initial projects coming from the general aviation side. So we used that tool to call the concept paper issue 1 at that time, and definitely when it comes, let's say, to the time to do it, we will take the same approach in large transport for large transport aircraft in CS25 until we have, I would say, undergone the rulemaking activities that Michael was highlighting. The point being, the concept paper was meant from the start to be first usable guidance, so to provide not only visibility but also material. If we wait for, let's say, 2, 3, 4 years just because we have to undergo rulemaking to provide requirements to applicants, obviously we are not doing a good job. CRIs, so certification review items, are a very powerful tool in certification projects. We could have gone for CRIs at project level. We prefer to go visible with a special condition, and we will carry on this strategy until we, again, we have more formalized requirements and sets of AMCs. One thing to mention still is we have anyway discussions with each and every applicant in the framework of each project based on the special conditions. So it's not enforcing necessarily a paper that we always say is not necessarily at the last level of maturity. Therefore, it's very important to say project by project, we definitely undergo an exercise of assessing which objectives are applicable, which ones might be different for a type of application or technology, etc. So that's the answer I would like to provide. Thank you.
Compliment with,
yes, please.
Sure. Just 2 sentences. In addition, what Guillaume mentioned, for the special conditions, they are project specific. They can be generic if we know that there are several projects, similar projects coming up, but at that point where there's new technologies, we are not in a state to already draft certification specifications. We need more experience, we need more practical experience to see how that works. So that's where we typically do not immediately turn to CSs, but work with several projects and special conditions, and then develop the certification specifications. Otherwise, we risk to be very product or technology specific and then close the door for many other things.
Okay, we have another question that it's on the top of my list, so it was really reinforced by many people, and it's for EASA also. So could EASA please tell its plans for using AI to accept certification programs and define level of involvement, get satisfied with the compliance documents, and determine DOA scores?
Yeah, that's a difficult question. I would just answer saying we will follow the same layers or type of requirements we have already today. Definitely we will have to think one step further into what LOI definition or criteria might trigger specific aspects, like, I don't know, level of AI might be one of them. This is something we will need to prepare, but I would say, considering the current logic for the different panels involved, whether panel 6, panel 10, panel 12, we will use the same logic and strategy for level of involvement definition as of today, and the same principles, let's say.
Okay. So I think I have another one for Michel. Yeah. So under your part AI AR, can you confirm your objectives are at the highest aircraft and systems level and not replacing or trying to duplicate ARP 6983 on AI for a machine learning similar system? Yes.
No, but looking at you, but a clear no. So it's really the requirements. It's not talking about standards, technical specifications. They do not belong into the part AI.
Okay.
Just to complement, or my view at this stage is the standards will be called by AMC material like it is today. Now we cannot say, for instance, if I take just an example, it will be an AMC 20 calling directly the standard, because at this stage we try to do exactly what Michel described, a domain agnostic first thinking, and therefore we need to find the tools to do that. But after, at domain level, if we think initial airworthiness, definitely it will be called by an AMC in the more traditional way we know today.
All right. Lots of questions. Another one. So when EASA speaks about learning by doing, you refer to IPC projects or by Horizon Europe projects. So what else?
Yeah, I'm not sure I understand completely the question, but definitely learning by doing is IPC, Horizon Europe projects, research at large. It's also today, again, certification. We have certification projects ongoing. Sometimes you go one step further and in a very complete way on the objectives thinking and assessing means of compliance to all the objectives. So definitely all of this, all interaction, I would say, with industry stakeholders, research partners, even with academic partners, are for us the use cases exercising the guidance. And this is where I was putting the emphasis this morning on the use case project that is managed by Giovanni together with François. And they are, let's say, keeping a matrix of coverage to know that we have enough use cases to address every possible domain, every possible type of objective in the guidance, of course, but also every possible technology we are trying to address. So it's a quite structured way, yet we cannot do as much as we want. Sometimes we have many more use cases available than we can really follow. But definitely we try to have a mapping to be sure that we test extensively the guidance in all its corners, not to forget something on the side.
Thank you, Guillaume. So we have another question that is more into the partnership of the institutions, I guess. So EASA is making AI a priority, but we still struggle to have proper data gathering initiatives. For example, agencies like Eurocontrol seems not to have yet data gathering in their priorities. Is there something EASA can do to encourage European-wide aeronautical data acquisition?
Okay, that's a difficult one. I don't know, Sylvie, if you want to say anything about the Eurocontrol approach after, feel free. I would say on EASA side, AI, let's say, trustworthiness of AI is our priority today because that's what really we need to deploy. That's definitely. After we were asked sometimes, does EASA plan to have like, I don't know, a data set for testing specific applications? Maybe at some point, why not? But it's not a priority in the sense that there are so many applications, so many possible cases. But we have, I guess, across this ecosystem of players here, we have some, let's say, aspects like natural language processing for aviation, etc. And that's why I'm turning also to you, Sylvie, with things you do on Eurocontrol side. There are things we can do together. And if we are really collaborating all together, probably we can set up data sets that will be available or even models that could be let's say, usable and useful for a number of partners. This is not a priority set by EASA, definitely, I confirm. We will first deploy the guidance, and then we definitely work also in partnership with all people here to find out possible, I would say, cooperation possibilities around this data model management. And it has to, I would say, to please the whole community and to be really a synergy.
Okay, and sorry. Sylvie, go ahead, please.
Yeah, thank you. Sylvie Grandperec from Eurocontrol. As part of the network manager arrangements, we have set up a task force working on speech recognition, because one of the issues is to gather enough data that are representative to all accents, all dialects, everything. And as an ANSP, we cannot have all these data as alone. So we need to find a way to work together, and this is what we're discussing, to access the data, or eventually, as we are discussing with EASA, to have a federated learning approach where everybody could keep their data, so privacy of the data, because voice data is also biometric data, so we have to manage them carefully. And we don't share the data, but we share the model. And this is a new also issue regarding the certification, how we certify something that has been trained on data that you cannot prove because the others have the data sets. So they are new kind of issues that we are discussing with Guillaume and Francois at the moment. But be aware, yes, we as Eurocontrol, we relieve a number of data for research purposes. But there are also some cases where alone you cannot do it. We need to be together. We need to cooperate. And that's what we're trying to do. So if you want to join us, you're more than welcome, working with Airbus and other ANSPs on this.
Thank you, Sylvie. Very pertinent. Yeah, and I have another question that is really related to the data, so this is an important issue for sure. Is there anything being done to identify and protect the AI systems from intended fake data flooding? Luke, do you want to comment?
So I think it comes as part of the data management that you need to do, diligently anyway. But that there might be people who try to spoil your data is something that you should definitely keep an eye on and address in your cybersecurity program. I think people underestimate it as an attack vector. I think it's good to raise that.
Okay, I just got a question for you, Thomas. I think that maybe you can please put your mic on. So it goes a bit like this. So the V process is okay to manage the development, verification, and validation of models based on large amounts of data. For example, identification of flight dynamics model for critical flight control systems based on flight and wind tunnel. Is it different for machine learning models? Any specification problems?
Yeah, thank you for the question. So I think on the one side, you could simply state, well, AI models are data-driven. The success of the training, the safety of the system is dependent on data only, so we need a dedicated process for that. On the other side, as the question mentioned, so we, at least in parts, have it for aerodynamic data, for identification of parameters for flight control systems and so forth. So why do we need to do this? I think there are some aspects which link to this W model in a sense that the complexity of managing this training data is a little bit higher than before. I think with respect, for example, to synthetic data, the generation of synthetic data, the quality of it, and making sure that it is of a quality high enough to use for training is one aspect where you could argue for a dedicated step. Another step or another argument for that is the aspects which are rather related to ethics-based topics. So we had some research made in one of our projects with regard to a system which is tracking the eyes for for an operator and to see if the operator is tired. And the eye tracking system, when we digged a bit deeper, showed that it is giving different results for people with different skin colors and different eye colors. So it seems that the data used for developing this system is biased and not really fair. So also from this perspective, it would be necessary to have a dedicated step. Because in the end, if you would use an eye tracking system like this for the management or for detecting, is my operator tired, then it would be discriminating in the end, and this you wouldn't want. So this is one example why this might be the case, and maybe a bit more related to something like flight control or using AI components in avionics. Since it is so data-driven, we will in the end have a lot more scenario-based testing. And this scenario-based testing, from what we see right now also in the automotive area, will be done in an automatic way. And we need to be able to perform this in a sense of allocating the right training data to the right scenario and really prove the system quality in a lot of scenarios to be simulated. But it is an interesting topic. I hope it was not too long, but this would be my perspective on it.
Okay, thank you, Thomas. Mark, you wanted to add something, correct?
No, I would like to ask a question maybe to Samir, because
Sure.
I highlighted the fact that on the ground we are working on very prototyped things, and we also see now new artificial intelligence applications which are very prototyped. And I was maybe wondering how you would see the benefit, because it doesn't make sense if we use new technology to solidify, I think I have qualified that, fragmentation. This should actually be the opposite. The artificial intelligence should help us to get out of this vertical way of doing business. So how do you address, so what you have developed, can we use that in Zurich or in Paris, the algorithm, or do you need to adapt the algorithm to the new data set? How much data do you need to be that your algorithm becomes suddenly exportable? You know, so these are the questions. Also going back to EASA and Eurocontrol, who will provide us the real benefits from artificial intelligence on a network level and not just on a local level?
Yeah, it's an excellent question actually, because this is one of the biggest challenge we as machine learning scientists are facing about transfer learning. The models that are trained on a particular airport are sometimes very challenging to be used so easily on other airports. It requires an entire training regime, again hyperparameter tuning, so reselecting the parameters because every airport is unique. A case in point is the runway sequencing algorithm that I mentioned to you in the presentation. The initial prototype we developed was for Zurich Airport actually, with Eurocontrol Brussels as partners. But when we tried it at Singapore Airport, it failed miserably. We have to re-engineer everything and went through a different regime, because the controller in Singapore have a very different way of handling the traffic as compared to Zurich Airport. So not only the I would say air traffic data, but how the controller interact with the system also impacted a lot. However, we have one success story. The success story that we have is at the Houston Airport. So the software that we developed was for Saab Aeroban system. Saab Aeroban system is as operational at Houston Airport, and we implemented our aircraft tracking and distance estimation algorithm successfully into that. So what I would like to say is as follows. If the digital environment and infrastructure is already there, in case of Houston Airport, there was a digital tower interface already there. We can harness that much better as compared to the traditional cyber physical system that we have. It is much harder to bring AI and machine learning technology into a cyber physical system as compared to bring it into a new digital environment, for example, digital towers. That provides a much easier translation of these new technology into this environment. So it is like bringing a jet engine, trying to fit it into a four-cylinder car, right? It's quite difficult. So that's what my take. So I had two experiences where one didn't work, and at another place be very successful. Thank you.
Thank you, Samir. And maybe I see that the time has elapsed, but one last question for you, Yuri. And I take the chance also to thank our use case presenters. Really, that was great to have all of these insights. Yuri, you presented actually towards more the end of the scale we have for now on the plate with the level 2B. How close or how far do you think we are from technology that would enable this type of 2B operations that you were showing on your slides?
I think I can just extend on what has been said by Samir and Mark as well. It depends on the use case and how wide a use case you want to have it support, so to say. Give a simple example, back to what was just discussed, also for a human being, when being moved from, let's say, Brussels Tower to Antwerp Tower, you say, okay, these are both Belgian towers. Again, they have to go through months of training, and this is a human with maybe thousands and thousands of operational experience that still needs to go through that. So for systems will be the same. So in terms of, back to the question, putting that into a cockpit perspective, yeah, if we say, all right, we'll train it for a particular situation in a Falcon aircraft, then I don't think you can apply it immediately in an A320 for all type of applications. So we really need a lot of time and go through all the scenarios. You remember also that for the pilot state monitoring, the three kind of pillars we said, okay, for depending on the person you're looking at and all its characteristics, depending on the dynamics of that person itself, and then the dependency on the dynamics of the external cases. There's a lot of variables again there that you have to pull it through.
Thank you. So questions and answers are over now, and we pass to the end of the day, last part of the works of today. Thank you for everybody.
Thank you.
Thank you.
So thank you very much to everybody on the last impromptu panel, shall we say, here almost. We're now going to come to the challenging task, which we're giving to our Flight Standards Director, Jesper Rasmussen, of pulling together what's happened today and drawing some conclusions. So Jesper, over to you.
Thank you very much. Such a daunting task to summarize what has happened today. Well, I will come a bit back to that, but first, we're coming to a close of this conference day. And I would like to, on behalf of the EASA team, to express my sincere gratitude to all distinguished speakers, panelists, moderators, and attendees for their invaluable contribution and active participation. It's you making the conference. My impression is that the first day here has been highly productive. Well, that's my impression. I hope you share it. Let me just run through what we actually have consumed, because it's quite a lot. We explored the AI regulations set by the European Commission, the overall umbrella, and outlined the possible and anticipated impact on the aviation domain. Then we dive deep into the new EASA Roadmap, AI Roadmap 2.0, timeline, action plans. We shared insight and best practices from industry experts on concrete use cases. And finally, we have examined the regulatory frameworks and the details and the do's and don'ts in the regulatory work surrounding the AI deployment in aviation. I've been quite thrilled by seeing in the Q&A sessions that you have been very good at using the Slido to get a lot of very interesting questions put forward, also in a prioritized way, so we could take first things first. Actually generating a lot of also very interesting responses from the panels we have seen today. And now to the daunting task. What do we take away from the day today? Well, let me try with 3 points. First, the number of use cases have been impressive. they're there. It's like springtime. It's coming out of the ground. Some are even approaching certification or under certification. That means that things are getting really concrete. Still level 1, okay. Level 2 will come a bit down the road, but things are getting concrete now. Then we have seen as a point 2, 2 approaches, the data-driven approach and the rule-based approach. We have seen pros and cons for each approach. Sometimes they can be combined. We can even move into hybrid projects. Still to be seen where it will end. Will one be more used than the other? But we have 2 ways of going as we see it now. Item number 3, or point number 3, autonomy. We all speak about it. I like very much the picture of the car, of the gear and the engine, that it's autonomous, yes. But what is autonomy? I think we need to define that concept. It's so central for everything we do. So there's some work to be done there. We have to agree upon such a definition. So that was an attempt to highlight 3 items which we can take with us, both for tomorrow and in the near future. Now, of course, we would like you to contribute, to work together with us in EASA on how to roll out this roadmap 2.0, because we cannot do it alone. But before coming to that, we also have a day tomorrow. It's a slightly different one. It is a day where we will learn more about a research collaboration called the MLEAP. And for those not fully into that, it stands for Machine Learning Applications Approval. It's a research project that EASA has launched under the Horizon Europe framework. We will dive deep into some of the projects, some of the insights from that overall program. And I hope that many of you, if not all, will stay and listen to what the researchers are coming up with, and which can assist us all, both in industry and as regulators, to find the way forward for introduction and implementation of artificial intelligence. I will not say more now. There is ample opportunity later today. I think it's at 7:30 over a glass of very cold Kölsch beer to discuss further and to network between you. So I hope you will go there, and if not, then I hope to see you again tomorrow. Have a nice evening. Have a nice evening. Bye-bye. Thank you.
So thank you very much to all of you for being a good audience as well, and also to everybody who is joining us from remote. The next part of it concerns the evening event here in Cologne. We're going to Gaffel am Dom. I think you have that in your agenda. Oh, there it is up there as well, because somebody always needs to press this. And, to get there, for anybody unfamiliar with it, you need to basically walk through the station. So you go, if you see McDonald's, then you walk past McDonald's, and then you go through the station, come out the other side, and then you'll see the Gaffel am Dom there. I know everybody knows how to use Google, but around the station area, it's a little bit complicated. So hope to see as many of you there as possible, and thank you very much for a great day.